you guys on mute for a second. All righty. And hello out there in YouTube land. Hopefully you guys can hear me. We'll see if anybody responds in the chat. I'll bet they will. This thing says we're live, so we'll find out in a second. We got Larry Scott in here today with me. Alan Evans is sitting around. And we're going to talk about something that upsets our friends on the flat earth side of life greatly. That is spherical excess. They hate it. Imagine that. I'm going to share my screen for you guys here in the chat, here in the Discord. If I can find it. There it is. Yeah, and hopefully you can see that. So say hello to everybody, Larry.
Hello, guys. This is Larry.
And this is Alan.
And a wonderful Monday afternoon it is. I guess it's Monday. Seems like it is.
Yeah, it took me a while to work that one out, actually, a little while ago.
Well, you know, there's been recently a fair amount of controversy over this idea that that such a thing as a spherical triangle even exists. It's hard for me to believe in 2023 that there would be people that wouldn't understand that when you draw a triangle on the surface of a sphere, you're going to get interior angles that exceed 180 degrees when you add them up. But there are people out there that don't believe that, believe it or not.
And it's not specific to geodesy. I mean, how many spherical, high pressure tanks are there? You welded together and all the sheets of steel, laser cut to fit together. It's in every CAD program. It's in every engineering. It is not unique to geodesy. And the fact that we could take an instrument out there on the face of the earth and measure the values which comport with the classic trigonometry.
Yes, they do. Every time.
And they don't like measured evidence. For some reason, they have to know the answer in their head, and any measurement that follows that is meaningless.
Well, and it's not a recent sort of thing. It's not that we just figured this out the other day. People have known about this for a very long time. And I think the report that's drawn a lot of attention has been the transcontinental triangulation of the 39th parallel, right? Now that thing dates back to, when did they start doing that, Larry? Mid 1800s?
Yeah, to post-Civil War. If you look at the the full disclosure of their raw data, almost everything is dated, date of observation, and some observations, particularly on the eastern seaboard, go back into the 1870s, a couple of them for 1860 and the like. And when the further you go out west, then there was a push and a campaign initiated in the late 1880s, which spanned the big distances, like from the Mississippi to the ocean. But you look at the dates, some of these things are brought together from measurements that were done, 20 years prior, 15 years prior, 10 years prior.
Yep.
So, the field books and measured data, it was accumulated.
Yeah, it was done over quite a long time.
Well, particularly when you're dealing with the eastern seaboard and the like, but when they made that big push west, that's when you see the dates compressed to like an 8-9 year period. But there were triangulations that ran north and south along from Maine to Florida, and those are significantly older. And that data carries forward. I mean, once it's measured, it's measured. Case in point, those locations, particularly in the west, they're still there. You can go back and remeasure them today, right? Or you could just use the measurements that they had. It's not a matter of authorship. They swear, that other crowd, they swear up and down they just made these numbers up or they fabricated them. And I said, well, they're still out there. They're in the public domain on terrain. You can go remeasure. If they think it's a lie, they can just go and remeasure it themselves.
You absolutely can. Those points are still there. None of it's gone anywhere.
Many of those points have recovery notes that are only 3, 4, 5 years old. People have been to them because they're on hiking trails on mountain peaks, and people, there is an avenue to where you can, inform the database. This mark still present, where it's condition, and sometimes they provide photographs. So yeah, go back and remeasure it.
Oh yeah, people will take pictures of those monuments.
Yeah, all they need to do is pick a couple of major triangles and just remeasure just a couple of those angles to see if they match what was reported. You don't have to do the whole thing.
Yeah, exactly. Well, you're a surveyor, Larry, so maybe a good way to start this is give people a little feel for why you would do triangulation. What is that all about? When they say triangulation, what the hell do they mean?
Well, in the pre-electronic world, distances were very, very elusive and difficult to do. So across a portion of flat valley, you can measure a distance of say 6, 8 miles, 10 miles, sometimes a little shorter. And they would spend months and months measuring that one single distance. Now to get distances across an entire state or multi-county area or all of North America, by triangles, you can build on that one. You build all your triangles, and geometrically, that's a rigid figure. And as you measure some of the sides, that gives all of it scale. So to measure from Washington, D.C. to Four Corners, you're not going to pull a tape measure that length, but you'll buy a series of triangles and enough distance measurements of portions of those triangles to scale the whole lattice.
Right.
And these days, of course, now it's all electronic. So there was a period of time where lasers showed up, and then they could measure more distances, many more distances, but not all of them, because lasers, once you pass 15, 20 miles, it gets kind of hard. And now, using satellite geometry, satellite work, nobody uses a laser much either. So distances were always elusive. So you would build your triangles across the landscape, and you would measure some of the sides to an extremely high precision, because you may have 200 lengths of triangles, but you're going to measure five sides. So you'll measure that to like, a half a part in a million or 3 parts per million. And then all your angles also have to be very, very, very high classification to avoid accumulation of error. And then the precise latitude, you can calculate the precise latitude and longitude of all vertices of all the triangles for the entire connected chain.
Yep.
And then that becomes the base for mapping. From those primary points, then lesser grade surveys are brought down into the lower elevations and higher densities so they can make 7.5 minute quad map that we all, the U.S. Geological Survey. Because there you got the different divisions. You got U.S. Coast and Geodetic Survey, now called the National Geodetic Survey. They put in their primary lattice, that core. And then the U.S. Geological Survey went intermediate between those, generating the maps of which everything is based. Highway layouts, railroad layouts, agriculture, municipalities are all based on, the series of maps. And for consistency, you have to have a very strong network of measurements that may span 400 miles or 200 miles, while they're making maps that span 20 miles. But then you chain them all together, the edges have to match.
Yeah.
And this 1900 survey goes, everything is pre-electronic. There's no machine there's no automated calculations.
Not a one.
Orientations are done as was done for the past, for the 100 years prior and for the 100 years afterwards, done by, observing, Polaris for azimuth and different transiting of stars for latitude.
And pulling chain where you could for distance.
And then there's still, when it gets into distance, you have longitude problems, because that's time.
Right.
That's measured. That's, we know, longitude is defined by the transiting of a star over your meridian, and that same star over any other meridian. You have to have time. Well, in pre-electronic world, longitude was very, very difficult. And this survey here had the marvelous technological advantage of having time transfer by telegraph, which was magnitudes more precise in longitude control, which again was a good, scaling. So you can measure, you have the measured distances by the triangulation, and you have the longitude differences measured by astronomy and telegraph time transfers. Now you know the shape of the Earth, you know the dimensions, you know the dimension of 1 degree of longitude at that latitude.
Right.
And the cone it generates.
Yep. Well, that's where the 39th parallel is, that yellow line that I just put up there on the screen. That's the 39th parallel, and it starts over on the eastern coast of the shoreline of the Chesapeake Bay, sort of due east of Annapolis, I think, and runs to the west coast up north of San Francisco. So that's the thing that they're talking about when they say the transcontinental triangulation of the 39th parallel. That's the 39th parallel. The red line is the Great Circle course, Great Circle route, courtesy of Google Earth. Thank you very much. But it was pretty amazing, the stuff that these guys did. I mean, absolutely amazing. That's a picture I pulled out of the report. It's Cimarron Canyon. A photograph they made from up on top of. You help me out with that name, buddy. Uncompahgre Peak. What's the name of it? What do they call it?
Uncompahgre.
Uncompahgre Peak. Yeah. That's what a survey crew looked like prior to 1900.
Particularly go out west, and again, the narratives in the report are just, some of them are just quite charming. They talk about, they could use railroads and they could use carts and horses, but then when they got out into the, true frontier, they had to blade their own pathways and roads and build some bridges. So you had a construction crew, you had a cook crew, you had, crews to erect the tents, bag the food, and then you had crews to carry the instruments and maintain the instruments, and you have different crews to operate the instruments, and then you had to have the teamwork of crews on the surrounding mountaintops supplying, the signal mirrors so that they could make the observations. And this is all done without radios.
Yeah.
In areas with almost no telegraph availability in out in the frontiers. And
well, there was certainly no telegraph availability up on top of one of those mountains.
And they were multi-day,
If those guys wanted to communicate with another survey crew 50 miles away on top of another mountain, they did it with a signal mirror. That was the only way they had.
And so there was the coordination of having, 5 or 6 of these mirror crews, illuminating a central instrument station while the angles are being turned. It was a matter of dedication, because you can't call in sick that day.
No, not hardly. Yeah, just imagine the problems having to haul that stuff up and down the side of a mountain on the back of a mule.
They were moving tons of equipment. So it was a very, it was a military grade operation, the highest level of science, and the procedures and requirements to really hold on to the fractions of arc seconds. It rivals whatever they did at CERN, at the LHC. I mean, it's that level, given the technology of 1900, 1890, 1870,
Yeah,
specially made instruments that
they're very special. And some of those theodolites they were using weighed 100 pounds.
Oh, easily. By the time you put them in crates and everything, you multiple 100 pounds, because they had to disassemble them to move them. That's how big they were.
Yeah, that's a fact. In fact, let's see. I think I got a picture there. Well, that's not the.
Those are the heliotropes.
Yeah,
those are the heliotropes.
Those are heliotropes, and if you don't know what a heliotrope is, that's a mirror.
Yeah, in the aiming situation, they can reflect the sun right back at. But I'm just surprised how small those are.
Yeah, I read that. I read in the report that they used, depending on what distance they were working over, they had some as small as 3 by 3 inch mirrors, and then they had 4-inch mirrors, and they had some that were even 6 inches. But it's still pretty small when you think about it.
Now, even in my work, not recently, of course, but I would use the an Air Force survival signal mirror.
Yeah.
And you could see that son of a bitch for like miles and miles and miles. I had, just your basic 4x6 signal mirror, and I was off on a ridge, and the other observer was about 14 miles away, and he couldn't find me because he thought I was halfway up the slope. And then when he said, "Oh my God," when he did see me, it was just, it's like, like a laser beam. It was so brilliant at 15 miles away.
Yeah, well, I've seen,
these guys are working at 100 miles.
Yeah. Yeah, I've seen a few of these people make comments that, this is all bullshit. You couldn't possibly see a guy 50 miles away. Well, of course you can't. Nobody says you can. What you can see is the bright flash off a mirror on a clear day when the sun's shining. You bet your ass you can see that.
Hey,
And
yeah,
that's what
just
they
think
were
for a
looking
second.
for, just that little pinpoint, bright light flash.
Yeah, consider looking out at the horizon at night, like particularly in the western desert areas, and see all the red lights on radio towers that are 50, 80 miles away, 100 miles away.
Yeah, it's no problem seeing them. Strobes
So
especially, which is more similar
example.
to, yeah.
And we have that example of seeing a high intensity lamp at great distances, like lighthouses and the strobe lights on top of radio antennae. Yeah, you can see those 40 miles, and a heliotrope reflecting the intensity of the sun. Yeah, that's that bright.
At least that bright, if not brighter. That's a theodolite that they used back in those days. Take a look at that bad boy. That thing, that's one of the small ones. That one's only 20 inches.
That's an East Coaster.
Yeah, that's a 20-inch telescope. You want to see one of the big boys? It's that thing. That's a full 1 meter telescope.
Yeah, it's got very, very high magnification, very narrow field of view.
Yep. But a marvelous piece of machinery.
I mean, we can see stars as a little point of light.
Yep.
Oh, but they're just lights on the dome. Sorry, I just had to throw that in there.
There's one of the enclosures that they built. Notice how they just stacked up stones around it to protect it from wind. It's really a tent with a roof on it.
But also that stone ring is also like a thermal barrier to provide a more uniform heating, so you don't have the sunlight on one side. And wood, like they're holding up the tent structure, that's too valuable. They moved the wood, but yeah, they built with local materials, which is why they had a construction crew go out as part of the field team, and it could take them, many days or a week to get an observing station, put up to where they could bring in the big gun and get to work.
Yep. Yeah.
And the cook crew, and a cooking crew to keep everybody fed, and a supply line of food.
Well, and shelter for the guys to live in. They had to have tents and things.
The point is, they really did this, and they laid out as much documentation as you see in any endeavor, including photographs.
Yeah, the amount of
photographs.
Yeah, the amount of documentation in that report is phenomenal.
And that's just one of many surveys, but that was the most significant because it was done in one fell swoop, even though that could have been, spanned a couple decades. It began on one end and ran to the other end, 4,224 kilometers.
Got a $5 super chat from Witsit who says, it says in the PDF that they used a weighted equation based on the reference spheroid, and additional corrections are further based on the reference spheroid. Huh.
Well, that's true there, Witsit. They did exactly that. They provided the raw data, and they did an adjustment based on Clark 1866. And that was labeled preliminary, and you are free to take raw data as presented, and the raw data is very explicitly laid out in there, and reevaluate the whole thing. And as we said, Witsit, those points still exist. You can go and remeasure them today. You don't have to measure all of them, just a couple. Just a couple, I dare you. Way cheaper than build the wall.
You want to comment on this graph, Larry? I know you've seen it. I know you've seen it before because I got it from you.
Well, MC Toon forwarded that, and it came from Stark Odd. or Stark Odyssey.
Stark Order.
And he had taken the spherical excess as observed in the raw data and plotted that against the area of the triangle on the x-axis and the spherical excess in arc seconds on the y-axis. And there was that big argument that in the east, they had some triangles that were slightly deficient. And those triangles are down there in the lower left-hand corner. And as you get into the more significant areas, some of these are multi-thousand square mile triangles. The uniformity of that is exceptionally high, where the spherical excess is uniform based on area of the triangle incorporated. And these are hundreds of data points, not a couple of oddballs. And down there in the lower, near the origin in the lower left-hand corner, yeah, the spherical excess is so small, it's nearly impossible to measure given 1 arc-second instrument. So that was a good example of going through that report, pulling the raw data, and just plotting it, a separate evaluation, independent of their adjustment. They just took what their measurements were and plotted it.
Well, yeah, this is exactly why we have said, I don't know how many times, that we pay no attention to spherical excess on small triangles, local surveys. It doesn't make any difference. You can see it right here. There's no point in it. It's almost nothing anyway. Just treat it as a planar triangle and be done with it. Who cares? Because
it's too small. It's too small. The work I've been playing around with in Shenandoah Valley, I only have 300 square miles to work with. Right? I don't have 300 square mile triangles. I have a bunch of smaller triangles.
Got another.
And again, it goes to the fact that they ran an adjustment of the raw data to show the integrity of the measurements, and they supplied the raw data so you can reevaluate it yourself. And this was preliminary, marked preliminary, and it took them years of further work to go through and make the fit in measuring and determining A and B values and 1 over F. As titled, to determine the figure of Earth. They already knew it was a spheroid. That was not a point of discovery to see if it's a spheroid or to see if it's a globe. Those things were well known. They were trying to refine the dimensions thereof. For some reason, they hate that. They think it's still a point of discovery, like the South Pole doesn't exist.
Got another super chat from Whitsett who says they provided the observed angle after the weighted mean equation was applied. Raw data would be all the observed angles before that correction. We're going to show you that. We're going to show you that in a minute, Whitsett.
It's in the portions of the report labeled abstract of angles, of which there are no corrections. And then they did do an adjustment, secondary, but the raw data is still present, of which Whitsett may compute himself and see if.
I know you and I have looked at this one area. This is out in the Rocky Mountain area, right? Colorado, Utah area. And this is where they had gotten into the larger triangles where you have enough land area under that triangle that spherical excess becomes significant. You don't have to worry about a few tenths of an arc second or 2 or 3 arc seconds for that matter. The spherical excesses are in the range of 30 or 40 or 60 or large numbers of excess. So we had to look at that one. Let's move on to that little diagram. That's just the center. Let me back up. In the circle there, just this area. I don't know if you can see my probably can't see my cursor, but what's in that red circle is blown up here. And you've got Mount Was there in the center, and then you've got 4 points around it with 4 corresponding triangles. So the observations we're about to look at are all made at Mount Was, right? Let's have a look at that.
Well, yeah, all 5 of those points were occupied, yes.
Right, right.
And as was right there on page 556, that is the abstract. That is the raw data. If Wixit wants to assert that these raw data are not raw data, he's going to have to go through and find where that abstract is not as observed.
Yeah, this is page 5.
Later they do an adjustment to show the integrity of that, but that's still present. The raw data is there. I recall some days back, somebody said, why don't they show the raw data?
There
Right
it is.
there, page 556 is one example. And all the triangles that are listed later come from the abstract.
Yeah, that's the data as observed. Let's see, I probably have that. Oops. That's not what I was looking for. I'll find it in a second. What is this? Oh, imagine that, page 556. Hopefully you can see that. And those columns are observed, objects observed. Okay, that's the first column. Resulting direction from station. And then it says adjustment. What does that mean?
And they give the name of the observer, the date, the instrument, serial number, full disclosure. Station occupied, Mount Was. Observed plate angle at Mount Ellen and the observed plane out at Podbray. Subtract those out and you get the interior angle of the triangle with Mount Was at the vertex. Just subtraction, not
Nothing else.
Not come up or smushed around.
Then they give you an approximate probable error, which is essentially standard deviation, because you don't go out and make one measurement. You go out and make 20. And really what they were doing was making a measurement early in the morning and another one late in the afternoon. And they were
accumulating about 16 or 18 repetitions across those marks.
Yeah. Yeah, they would do it over and over again, early in the morning, late in the afternoon, to build up a data set. And from that, you can figure out what your standard deviation is. A single measurement's of no use to you. It has no statistical validity at all. So there's the error. And then they make there's a very minor, look at these little tiny adjustments that they're making here to bring that triangle back down from the elevation it's at. Some of this is up at 14,000 feet. They want to bring it back down to sea level. So you get a small adjustment for that. And I'm not really sure what corrections for figure adjustment is, but they're tiny little numbers to look at them, you know, particularly this one for Mount Was. That thing there.
Yeah, so in some of these major triangles where you're seeing 50 or 60 arc seconds of spherical excess, that's for the whole triangle. That's 20 arc seconds per angle, or one third of whatever that excess is per angle. Now, with standard deviations of 1 second and 18 repetitions, the statistical value, the statistical accuracy of that angle is definitely sub-second, but they have over 20 arc seconds in these really big triangles.
Yeah.
Anybody and their brother could remeasure that angle and end up with a few seconds different, of course. but not 20.
Well, look at how much it changes things. Mount Ellen, for instance, the seconds change from 33.940 to 33.982. 0.042 seconds of arc. That's the that's not much of a correction, is it? Same thing at uncompagra. It goes from 31.107 to 31.178. So you get what 0.6 arc seconds or something like that. Yeah, not a lot of change in that. You can just go with these numbers. Just use these. That's all. That'll be fine. These are totally uncorrected. Nothing added to them or taken away from them.
And part of the variation of across the multitude, 16, 18, sometimes more, that were taken over, multiple days, is to sample the engraving errors in the instrument. Yeah. So the plate is rotated, and you end up with these small variations. Much like if you're using, measuring blocks or micrometers, you do the same thing. You get these little variations which are inherent to the instrument, and you statistically sample that. And yeah, nothing is absolute to an infinite number of decimal places, of course. But
the error analysis is so high.
Yeah, so let's move on to, there I had thrown another slide in just to point out that tiny correction that's made to the final seconds for triangulation purposes. Now, they actually use that corrected number in the report. We'll be very clear about that, but also be very clear that it makes almost no damn difference. You could ignore it altogether and just use these measured angles with no correction whatsoever, and you're still going to end up with 35 arc seconds at the end of the day of spherical excess. It's not going to change anything. Now we move on to page 565. And here looking at number 11, that's that triangle we were talking about, Mount Was to Mount Ellen and to the uncompagra thing. And the angle, this angle that they're showing here, 143 degrees. This is odd. I wonder why they did this, Larry. 58 minutes, 63.143 seconds. I don't know why they left it like that, but they did.
That is common. That they do that a lot in many section almanacs, everything, because they didn't carry the one. That's well understood. There's no ambiguity there.
Yeah, it just looks funny to me. But anyway, so that's another way of saying that. It's 143 degrees, 59 seconds, 59 minutes, and 3.143 seconds, right? That's what that's telling you.
And again, that 36 seconds is the excess of that triangle as observed, okay? And as you move to the right, where they have spherical excess computed, that is stated clearly on page 47 as against the Clark 1866 ellipsoid. And the differences show that the inaccuracies of either the Clark 1866 ellipsoid values and or the field measurement. And there you can see a half a second.
Yeah.
So one is, that's an a priori value. Clearly stated as based on the Clark 1866, and the left-hand columns is purely stated as observed. They measured 36 seconds of excess, and Clark 1866 predicts 35.6. That was the point of the survey.
Yep. There it was. So I ran through this quickly just to make sure I understood too. I wanted to know. There's a blue triangle down there at the bottom that we've been talking about. If you take those angles shown in the abstract, 273 degrees, 50 minutes, 31.178 seconds. That's the angle with that tiny correction added to it. You can back that out if you want to and redo these calcs, and you'll see it won't really matter. Same thing at Mount Ellen, 57 degrees, 49 minutes, 33.982. Take the difference between those two. You got 216 degrees, 0 minutes, 57.196 seconds. That's this angle. That's the exterior angle. We want the interior one. So we subtract that from 360, you get 100. Whoops, what did I just do? Subtract that from 360 and you get 143 degrees, 59 minutes, 2.804 seconds. Where does that come from? Plus 339. That's this correction that they showed. That's been added into this number, or been taken away from it actually. So we need to add that back in, and you get that number, 143, 59, and 3.143 seconds. Pretty neat, huh? And again, take all
And
those
the normalized
take every one of those corrections out if you wish. Be my guest. I should have done that. I didn't get around
and the
to
normalized,
it.
the normalized formulae going through the adjustment is the adjustment of all the data against a known ellipsoid. And this, as stated, is to refine that ellipsoid. So you're looking at these differences.
Yep.
But even still, these measurements confirm the Clark 1866 ellipsoid ain't that far wrong. Fractions of a second. And if you look at the areas of these triangles, that triangle down there, then highlighted in blue, is several thousand square miles in one singular triangle observation.
Yep. So you can do this yourself. You can go through any of those observations, go to the abstract first, find these angles, or just take the raw angles without any corrections and forget about all of it. Add those up yourself. You'll still end up with 35.5 seconds of spherical excess. The corrections really don't do jack to this thing. Oh, there's an interesting one. You can talk about this one, Larry. Where'd Larry go? Did I lose Larry?
No. Say again? Oh, there we go.
Yeah. I said, why don't you, this is yours, why don't you explain this thing?
Well, that is that same, the blue triangles, the one at the base from Mount Wasp, Mount Ellen, Uncompahgre. And yeah, that's 2,600 square miles with a 36-second excess, measured excess, not calculated, not presumed, observed. And you look at the surrounding three triangles, each one of which has an observed excess. Now this is, I did not pull the Clark 1866 predicted values. This is field measurement. And when you look across that in the polygon of four sides, you have 11,555 square miles with 169 degrees, or I'm sorry, arc seconds of excess. Now, that's not even a degree, and that's a very large area. So it's kind of like the same thing where Bev thinks he can, prove or disprove curvature at 300 yards. Well, if you have a triangle that's only 50, 80 square miles, you're not going to find anything. So you've got to go big, where the dominant difference you see is the shape of the Earth.
Yeah, you can't really do this on little small triangles. It doesn't work. Well, I say it doesn't work.
Yeah,
it's just you're down in the noise level. Your measurement accuracy
and again, this
just
survey
isn't
was
that
done.
good.
Yeah, and this survey again being done in the late 19th century. Yeah, there is technology that only did this good, but you can go out there today and you're not going to find anything significantly different.
Uh-oh. We're going to hurt some feelings this time. These are the zenith angles from those points. What do you notice about that? Well, let's see, 90 degrees and some minutes, 91 degrees and some minutes, 90 degrees, 91, 90, 91. My goodness. Larry, you're walking downhill every direction. What the hell is going on?
Yeah, in all cases, the distant point is below the local horizontal. In all cases.
Yeah.
It's not like one side's looking up and the other side's looking down. I take that back. With the singular exception of the point from Tavaput to Mount Wasp, which is only 7 arc minutes above local horizontal at Tavaput. So you can see these points here. This is making like a dome. The point in the middle, which is similar elevations to everything around it, is still below. In all cases, all points are below eye level with that one singular. It's almost. So there again, drop from the horizontal. Yeah, observe. Because these lengths of these sides are like 80, 90, 100 miles.
Yeah. Yeah, these are zenith angle measurements, folks. If you don't know what we're talking about, this is the angle measured from the instrument's zenith. It's plumb line, so to speak. Vertical, if you want to use that phrase. Gravity, if you want to use that one.
And these are as observed. Refraction has not been removed. So there is these zenith angles in a geometric sense, or if you're in absent atmosphere, all be greater. Refraction of the atmosphere reduces those zenith angles. So they'll be even larger by some tens of arc seconds each. But again, the report lays it all out. They didn't hide anything. They're not fabricating anything. You read through it thoroughly read through it. Find exactly what was done, and you can find the as observed data, as presented, observed data, and yes, they did an adjustment of those data, provide latitude and longitudes to show the integrity of those data, and allowing for anyone to do the adjustment themselves, put their own science on it, put their own math on it, do their own computations on the raw data, and find problem with it, or redefine, find a different A and B value and flattening factor of the ellipsoid. Go right ahead. That was the point. And it's, as stated in the introduction, these data are presented to academia. This is not interagency. They aren't just talking amongst themselves. These are hardbound books that were published and submitted, supplied to geodetic institutes in Europe, South America, Australia, everybody interested to get a copy of this survey to do their own investigation of the science of measurement.
How about this one, Larry?
Now, in this case, we have a major east-west line that runs 427 miles. And as you can see, those lines are almost all cardinal because it's along the 39th parallel. And if you look at, these are reciprocal vertical angles, and if you add them, you end up, oh, they're always greater than 180 by a lot. So you can see we're in excess of 1 degree at the first course, 1 degree 28 minutes in the second course, 1 degree 20 minutes in the third course, 47 minutes in the fourth course, 53 minutes in the last course. Now, if you go through that, if you add up all those excesses, you're getting the central angle, center of the Earth. In other words, you're getting nautical miles per degree of great circle. And that would be 52 arc seconds or 54 arc seconds per mile. This mathed out to 46 arc seconds. Still very much curved. It's a little bit less by standard refraction. This has an approximate coefficient of refraction of 0.13. Whenever they say standard, we're talking about 0.14 or 0.15. So this is in the higher altitudes, and refraction is less by a little bit, yeah. And again, these are as observed, right from the report.
Yep. Yeah, and on zenith angle measurements, it's important to keep in mind that refraction matters on zenith angles. That will be affected when we're talking about triangulation. Refraction doesn't do very much.
And you can take any one of these courses or all of them, and you end up with a very uniform 46 seconds of curvature and refraction combined per mile, whether it's the first course, the last course, or all courses together. Yeah, given some variation, yeah, they have temperature and pressure measures the whole way. You could reevaluate each one of these individually. I just did this in bulk to show in gross, without using much math at all, the curvature is revealed over a 427-mile arc. So combined zenith angle excesses and spherical excesses, you're a long way from flat. You can't make flat show up.
Nope.
They did not invent curve and stick it into the numbers. The numbers are laid bare. Feel free to calculate yourself.
Yeah, let's see what we got next. I like this one. How do you like that, guys?
Yeah, that's a deep, that's one length, that's at long length, which is 182-mile long singular observation of reciprocal vertical angles. Heroic distance. And those points exist. The numbers for the latitude and longitudes I pulled from the NAD 83 adjustment, which they use the same data and readjust to the WGS 84 ellipsoid, slightly different A and B value and flattening. And again, this is like from the report. Feel free to recalculate it yourself. And there again, 46.35 arc seconds per mile with a curvature and refraction. Refraction there is 5.6 arc seconds. Curvature, as we know, is 52 arc seconds.
Yep. That's pretty plain, isn't it?
you can go and repeat it. Knock yourselves out instead of just saying it's wrong from your armchair, or it's lied. They lied to you because it's in a nice big book, but they laid it bare.
Oh, but we have this little thing. Uh-oh.
You have the site map? You have the site map?
Yeah, I do. There.
Now, in this case, I have done my own work. This is what I had done with a guy in Maine and Jesse. And we got onto a portion of Great Circle and we measured the distances between our points. Just that simple, just pure distances. No angles, no optics, just measure the distances. Now, obviously, the distance from one end to the middle and from the middle to the other end should equal the distance from end to end, but it doesn't. And this confirms again, the radius, as we've been told, shows up in pure, simple distance measurement. Now, this is electronic distance. I'll give you that. But there's no shame in using newer technology, but this is unadulterated, measured values, point to point, not arc on the surface. This is chord, point to point, because with electronics, we can do that. So you can see from A to C and C to B add up to more than A to B. Recompute if you want. Remeasure if you want. These are public access points. Come on out. I'll walk you through it.
Looks like that.
Now,
These are GPS coordinates. XYZ GPS coordinates.
And
that one,
and
there's
it made
one for
it,
C, there's one over here for B.
And the arc was not measured. That was calculated.
Yeah.
The chords were measured. I just want to point out, I did not measure the arc, although there's a distance displayed there. That is computed. But the 419.339.863, that's as observed. No adjustment, no alteration. And 419.340.004, as observed. And the 838.231.753, a little bit short. It needs to be a lot longer if the Earth were fucking flat, and it's not. This is a measurement anybody can do, and you don't even have to redo it here. It can be done anywhere. Just go get some kit. Come on out. You can use mine. Bring your own. I don't care.
All you need is a GPS.
So there is my confirmation that there is a radius.
Oh, absolutely.
But I did that. That's not a cut and paste from a textbook. That's not the product of a Google search. That's a product of like 5 man days of work, because there was 3 of us involved, and it took us a couple of tries to get it pulled off because of coordination with personal scheduling. But Jesse and I did the left half twice, and we did all 3 simultaneous once. And then it was followed up with zenith angles to the sun, which returned the exact same fucking thing. Eratosthenes style. But this is not, again, this is not, the 400 or 500 meters that Bev wants to screw around with. That's 520 miles. That's 2% of the whole size of the Earth.
Well, this
to
is
where the dominant characteristic is curvature when you go that far. If you're only going to go, a couple of city blocks, good luck. You got to go big.
This is exactly what we saw when Jesse and Soundly did what they did down at Lake Pontchartrain. Only this is 10 times as long, or more, 20 times maybe. But exactly the same thing.
And of course, they want to piss all over that, but they're not out there doing it. They don't have the equipment. They're not showing what's wrong with the way we use the equipment. You could take our data, essentially, take our data, find fault with it, recompute it yourself. Look at the analysis any way you want, propose it, demonstrate it. This was demonstrated, state-of-the-art equipment, 21st century methods.
Hey, wait a minute. Something's got to be wrong here. Check this out, Larry. The distance from that coordinate to the origin is 3957.785. But over here it's 3956.746. How could that be? Oh, wait a minute. This is up in Maine, and this is down in Maryland. You mean to tell me we live on an ellipsoid?
Yeah, that's not. Yeah, there's not a true fixed radius for this arc. It's a geodesic.
That always blows me away when I see that. We saw it at Pontchartrain too.
Yeah, it's unavoidable. If you try to avoid curvature and you've gone more than a mile, you're going into mistake land. You publish that, you're in trouble. You'll conflict with every other piece of data out there.
Yep. That you will. Oops.
And again, the site map showing that was from Maine, southeast New York, to the western panhandle of Maryland. A significant distance.
Yeah.
And we did it with observations of the sun as well. Not dependent on either one, not mixing them together.
Yeah, there's the point up in Maine. There's the point down in Maryland. Yeah, that's a 520 mile distance.
And that took some man hours, and we deployed like $50,000 of equipment. Fortunately, I own my own, and Jesse and the guy in Maine, they had company gear. I just went out and did it. Okay, we did it. We mobilized. We didn't sit on, Googling around and saying, "Oh, look, fake, 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 fake." Okay, this is what turned up. The fact that it comports what we've been told means I can't argue with what we've been told. And yeah, this is just like the Lake Pontchartrain or Causeway, just bigger. And in this case, the three of us are at modest elevations. I believe they're like 90 meters, and I'm at 150 meters. Very similar elevation. Not mountain peak to valley or something like that.
Well, and as you say, this would work anywhere. It doesn't matter where you do it.
Oh, without doubt. Boys in Florida could do this exact same thing. They could find the arc of the Earth on Florida, which has like no elevation change, Panhandle to the Keys.
Yeah, you can do it there. You can do it in lots of places. It's better if you're at similar elevations. You don't have to take that into account, but it doesn't have to be either. You'll still see it.
Well, again, if you have minor elevation change, you're still going to get a big ass arc, big ass radius. Not going to match the book, but you're not going to be so far off as say, oh, there isn't one.
No, not over 500 miles. You're not going to be that far off. That Sagitta is what, 20 something miles.
Yeah, which also happens to be pretty freaking close to 8 inches miles squared.
Yeah, it does. Amazingly close to it.
Yes, 8 inches miles squared is an approximation, which is generally only used in more modest distances like 30 miles or 40, 50 miles. And if you're going longer than that, you're going to do more sophisticated maps. But if you're only working at 5, 8, 10, 15 miles, more sophisticated maps is not going to return a different answer. Now, in this case, at 500 miles, yeah, there's some differences. It's not a lot. So it just, like I said, this is an example of what the Coast Geodetic Survey did and Elliott Baird, and this is an example of what anybody could do. You know, anybody can go get proper GPS equipment or get proper theodolites. It can be done. Instead of get Bev screwing around with an auto level at 300 meters. I'm like, what the fuck's the point of that?
Well, just take this report, guys. I mean, it's easy to find on the internet. You'll have no trouble. Just Google the transcontinental triangulation and you'll find it. Go through there and see what you can come up with.
I bet you could put an MC Tune link. MC Tune has it linked.
Yeah. Yeah, I'm sure he does. I'll link it too in the description of this thing. There's a tremendous amount of data there, and all of it makes sense when you sit down and study it for a few minutes. And these silly, silly statements that I've been hearing people make, saying that where's the observed data? It's right there in the damn book. Look for it.
Yeah, you got Mr. Wixit right there, you know, saying, oh, they used all these harmonized normal equations. Yeah, for the adjustment phase. And they did an adjustment with the raw data. They didn't take the adjustment and invent raw data.
Oh, another $5 from Wixit, who says page 556 literally is not the raw data. It is one observed angle per location, and it starts with the resulting direction from station adjustment. Excuse me?
He didn't read very well. He didn't read very well.
I'm not sure what he's talking about. 556, let's go.
You'll have to scroll up to where they describe the abstract.
You happen to know where it is, Larry?
Well, let's go to page 556. See what we get.
There's 556. Resulting direction from station adjustment. What do you think that means?
Not network adjustment. That was that 0.33 second correction.
Resulting
want to
direction.
Argue about the
resulting direction
argue
from
about
station adjustment. In other words, which direction have you decided you want to call zero? I think that's what he doesn't understand. You can these are relative bearings. It doesn't make any difference. You can aim your plate on your theodolite in any direction you wish. Most of the time, surveyors, for some odd reason, seem to like to point it south and call that zero. And then angles are clockwise, measured from that point. That's all it's talking about. Notice every one of them starts at zero. But I guarantee you, every time they do zero, it's a different zero. It's not the same direction.
Well, they rotate the plate as well to sample the instrument. So they don't just put the same. They don't put zero on the azimuth mark every single time. They rotate the plate like 15 degrees, and then reread, and then put it on 30 degrees, and then reread, and then put it on 45 degrees, and then reread, and go all the way around the circle. That way, they're sampling the engraving and inherent variation of the instrument to get the values.
Which is for another $5, says they use an adjustment for the direction explained in PDF, and that page is a single angle per location, not the raw data of all the measurements. Give me a page, which we'll read it for you. You don't have to do a super chat. Just type something in the chat. Tell me what page. Give him a chance to do that. I'm sure that's discussed someplace, but I'm not sure where. Probably back up in the front somewhere, don't you think? The snark for £5 or €5 says, "Oh, the globe will win with its curve and its spin." One of my classics. Thank you, sir. I appreciate that. What was the term they used? Station adjustment. Let's see. I could try searching for that. Well, that's what we get.
Well, again, it begs the question: if you go out, if Whitsitt himself or anybody else would go out there to those locations today and measure the angle, what would they expect to measure? What would be returned by a second field observation today across those same points?
All right, here we go. Whitsitt says page 556 is the page you guys invoked. That page is not a list of the raw measurements. It is one angle per location. PDF explains you use a weighted equation before recording that. God. That is a single angle. We've already said that they make multiple measurements from each point.
It's repeated 18 times or so. Indirect, and they rotate the scope 180 degrees for every one of those as well. So they have what's called direct and reverse. That comprises one angle measurement. And they're at the station and they sweep around measuring all the points, and then they reset the instrument, sweep around, measure all the points, and do that over and over and over again. So now you have an array of these measurements from one occupation, which are going to give these tiny little variances as described as standard probable error of any one measure is 18, or 1 arc second. They have an array of over 18.
Yep. Exactly. I think he's really asking for something similar to what Jeremy was asking for. I think what he's trying to get to is, I don't see all the field books. I don't see all the field notes. I don't see all 18 measurements.
it just goes back to, it's like, find any one of those triangles out there in the field and remeasure it. And what do you think you're going to measure? What was reported in this document, or some number that represents 20, 30 arcs, 25 arc seconds, 15 arc seconds smaller? Is that what you think? Because these points, this was published for public application, and those points are still existent in the field today. Somebody went out there and remeasured and say, why do none of them agree with my measurements?
Whitsitt says, again, for another $5. Thanks, Whitsitt. They specifically state in PDF that a good portion of the measurements cannot even be observed and must be filled in using the reference spheroid. Do you have a page where it says that? I have not seen that. He says, the document says you have to apply a weighted equation to observed angles before recording them based on the spheroid model. Okay, show me where. That's talking about baselines. So, well, really, what we're trying to do is look around the elephant in the room. The fact that you've got 30 and 40 and 50 arc seconds of spherical excess is clear. None of the adjustments you see anywhere in here make anywhere near that kind of difference. The adjustments are tiny. So I'm not seeing it, but show us some evidence with it. I'll be happy to show it on the screen. Which it thinks it's back up in the front somewhere. I have not run across that. Let's see what section we're in here. Can you read that, Larry?
Which page?
37.
You know, I had just scrolled to that paragraph C on page 36, where it starts. The abstract of resulting directions from theodolite measures and the adjustment of the triangles composing the base nets together with the computation of probable errors resulting sides demand further exposition of the methods employed. The great majority of the angular measures were made in series with different positions of the circle. That's rotating the plate around so that you're sampling the integrity of the instrument and the engravings on the instrument. These are called directions. At 3 of the 4 base nets, we find some angular measures by means of repeating theodolites. In other words, they use set instruments most of the time and repeating theodolites only a couple of times. Slightly different architecture of theodolite. The least square adjustment to satisfy the conditions among the measured angles generally proceed by the method employed, correlate equations. By addition, the adjusted angles are referred to an initial direction and the results given in the abstract in the order which azimuths are counted clockwise for some of the base nets. The station abstract include a column giving rough values and probable errors of the respective directions, which were not in all cases computed and had therefore been made use of only in one instance, that of YOLO base, which will be explained later. And then they go on to describe how a circle is measured and the maths of dealing with an array of data from a single observation point. You're not going to get flat.
Okay. What's it wants us to go to page 40 or 41, he says. And we're looking for what? Let's see. Weighted equations. Here they're talking about errors, computing errors and things.
Well, I guess he has a problem with what they did. And he's not saying what the problem is. He's just saying there's a problem with it. I don't know. It's complicated. This is the highest science of handling the data. So he can remeasure it. He can reevaluate it.
Sure.
Maybe you can get a powwow together. Get a tiger team on it. You go out there, you're not going to measure 20 arc seconds different.
I'm not at all sure how these weight equations actually work. I haven't really looked into it.
Well, they did do an adjustment on the Clark 1866 with the raw data. They did not alter the raw data based on the adjustment. They got the adjustment and provided the input and an output. So you can take the input, get your own piece of software, write your own piece of software. And then again, you've got the zenith angles right there, in concert.
Yeah.
So, and don't forget the South Pole exists. The point of the data is to refine the figure. Discovery of the ellipsoid, centuries old already by this time. 17th century, they thought they were pretty sure it was a sphere. 18th century, they learned by then the technology had improved such, they learned it was an ellipsoid. And they measured the ellipsoid in 1760 and has been refining it ever since. And you're dealing with the technology advancements, further refinements, where now satellite geodesy has it, the consistency and errors in satellite geodesy are so low, you can't find any issue. Of course, satellite geodesy being orbiting satellites and the current state of technology, but it's not, you're not, even when I take my GPS equipment out and I generate a triangle with phase differential, and I take my theodolites out there and I measure the angles between those same points, as opposed to, and compare that to the angles generated by the satellite data, I'm getting similarities that are at the threshold of the instrument's resolution. So I don't know what his problem is.
Yeah, I don't either. Yes, I think he had another super chat up here for $5. Thanks again, Witsit. They use a reference spheroid to determine the weight equation, and they apply weight to the values based on the predicted value of the sphere model.
For the adjustment. Yeah, for the adjustment, sure. They did an adjustment. Nobody's questioning that. They provided the input data to the adjustment and the output values of that adjustment, which show the integrity of the survey because of residuals to the measurements. The input data still provided. I mean, it's not a point of discovery to see if the Earth is an ellipsoid.
No, not hardly.
And the output at the output by section 6 or 7 is listed as preliminary results because they say it warrants further computation. Point of this was to publish the raw data out there for academia to evaluate it independently and learn as much as they can and glean what they can and formulate their math models to match observation data. Does Witsit have a problem with the amount of spherical excess, or it's a mere existence?
Don't know. I think we'll get into. I think we'll get a little further into this before it's over with. But what I do know is the adjustments, and they show every one of them are minute compared to the spherical excesses we're looking at. So eliminate all of it. Just go with the raw data.
If the argument is that 36 arc seconds is wrong, is it 34? Is it 37? Or are you asserting it's 0?
Mac Toon says maybe I could give a step-by-step demonstration of how to take an average.
And a simultaneous least square adjustment is an enormous piece of math science. All right. And this was at the highest science of the day, greatly enhanced since by satellite geodesy. Yes, there are satellites. I'm fortunate. I have 4 dual frequency geodetic GPS receivers and a couple of 40 and 60 and 50-year-old theodolites. They return values so similar to each other. The electronics is not some fabrication, nor is an analog instrument some sort of fabrication. They agree with each other to extremely high confidence. And I don't deal with 400 and 500, 300 meter measurements. I deal with 20 and 30, 40 kilometer measurements, where the dominant measurement, or the dominant aspect of the measurement is in fact the excess you get in zenith angles, and the much less value in spherical excess, because you have to get into triangles that are 500 and 600 square mile encompassing to get a spherical excess which is observable by analog equipment. Or did they do the survey as a pantomime? Is it just one of those fake things that they published just to continue the lie, like all the other geodetic institutions in every other country?
Well, that I just put back up on the screen is what you got to get over. You got to figure out how that works.
And you could do that.
And that doesn't seem to be very forthcoming. And these are measurements you made.
The closest thing to a field survey we have is Jaron's, bored with his flashlight. And I observe the sun for azimuth all the time. There's a load of spherical trig and motion of the Earth that has to be addressed. I think the graph showing spherical X as a linear value, which is about 72 arc seconds per 1 arc second per 72 square miles. That's a very uniform value as presented in that graph.
That graph?
That one.
Yeah.
Yeah. So if Whitsitt has a problem, you're going to have to discount that, the uniformity of it, and to think he can go out in the field and return different.
Yeah. So I'll tell you what I think. I'm thinking about going up to 24/7 and see if anybody else wants to join into the chat. We could do that. What do you think, guys?
Yeah.
Yeah, let's move up there. And here we are. So anybody in Discord wants to join in, feel free. Don't everybody jump in at once. Come on up, Larry. There he is.
I moved him up here.
Ah, okay. Yeah, he may have stepped away for a second or something.
I mean, on a slightly different tangent, the other evening when I was out at an event at the village hall, I was chatting to a couple of the local farmers, and their tractors are now planting seeds in the field with 10 millimeter accuracy.
Wouldn't doubt it.
It improves the yield by a huge amount. And the other thing it allows them to do, also, of course, with the GPS, with a ground station, is they don't need to spray. They can use a hoe and hoe between the seeds to remove weeds and stuff. Because the system knows where all the seeds are. They were also complaining that a tractor has gone up in price by £79,000 in 3 years.
Good grief.
And that 20 years ago they were buying a tractor for £79,000.
That's a lot of money for a tractor. I don't need a tractor that
Yeah.
bad. That's for sure.
Yeah. Oh, and also apparently all this GPS makes the job really, really boring.
Yep. Stick a link
Yeah,
to
there you
the.
go.
Yeah,
A
as is
really useful.
it's going on in the chat, you know, again, we have the input angles, we have the adjustment and the output. The output is not fed back in and altering the input. We have input, and they did an adjustment against the Clark, show the integrity of the overall, and then label the whole fucking thing preliminary. And yes, some of these computations are so heavy that it was not taken to its ultimate conclusion, because that took years. The North American datum in 1927 was in 1927. So they dealt with these data for a couple decades and getting more data and resolving to its completeness. Again, not trying to discover if it's an ellipsoid, but trying to refine the values of the ellipsoid. I mean, the discovery of the ellipsoid, that's 18th century shit. We're spherical excess, also 18th century known observational dimensions of the planet. Unless Whitsitt is arguing that it's not a planet, he's going to have to get rid of the South Pole. Sunrise, sunset, eclipses, and tides. We know the shape. We moved on to dimension. And yes, satellites do orbit.
Yeah, I had to step away for a second. Anybody else join yet? No. Come on, guys. Get in the Discord with us. Stick a link out there, Alan.
There we go.
Yeah, there you go. Welcome to come in and talk to us.
Oh, look. And another $5 from Witsit.
Yeah, $5. Thanks, Witsit. What is applied to the observed angles before they are recorded? Where does it say it's just a raw average? Why can it not just be cited? Well, didn't know you were going to ask for it, to be honest. We'll have a look, though. I'll let Larry and Alan chit-chat, and anybody else that wants to join in.
I'm going to assume that the fact that they averaged a whole load of sightings and recorded one would have been done in the field notes.
Angles before they are recorded. Is anything applied before they are recorded? How in the world?
Yeah, you guys go right ahead and chat. I'm just perusing through this thing.
Thanks, Earth is Life. Witsit has solidified his place as the absolute top left. Congratulations and thanks for all the fish. Thanks for playing. By all means.
I know it's not popular, but I still think Lindsay Harris is the top leftist of the top lefts. Because you just can't debunk Lindsay Harris.
No.
Carl Edwards, there's an equation. There's tons of it.
Yeah, that's impossible. I agree with that. There's no way you can debunk Lindsay. because you can't figure out what he's saying.
Point there. Too much derp. Well, Tusk, mean is another word for average. I mean, it's completely different if you say, oh, don't be so mean, from, man, don't be so average. Oh, sorry. No, good point, though. Repo Sandman. You feel badly for Bev. He deserves it, yes. On the other hand, if Bev would win, then you would hear his voice all the time, and I can't stand that unless he'd speed it up to at least twice the normal. Hey, what? I shouldn't be so Dutch. I am Dutch. What about it?
I like the way Whitsitt is asking
Hey,
Tusk,
Balance
does
Truth,
he
you
really
already
not?
said that, and it doesn't matter. If Bob the Science Guy said that triangles have more than 180 degrees, that's simply on a ball, on something that is round, you know? This is context. Do you know that word, context? You might want to look it up. Oh yeah, you, you said that triangles don't exist on a ball. Yes, they do. Yeah, let's go Dutch, Repo Sandman. Pass the Dutchie on the left-hand side. So Dutch, yes, sorry.
You're across the other side of the little puddle from
And
me
while
then.
I'm the only one making noise.
Can you hear?
Oh, the globe will
Hey,
win with its
hey,
curve and with its spin. That was that song.
Are you
I did the
muted?
first recording of that together with my brother.
I think
With a little thingy that was really clever. And now I'm simply using Audacity, much easier.
I think he's muted somehow.
So true. No, they don't
Snark.
understand context. Wally, how are you?
Snark. Turn your volume up. You're not hearing us, Snark. Can you hear me?
No, I don't think you can hear any of us.
That was very easy. It says in this paper why some are less than 180 degrees. I think you're cherry picking. I can now, yes.
Oh, you can hear us now, can you?
Something is wrong here. Don't know. That's strange. I can only hear the stream, not Discord.
Yeah. Snark's not hearing us. What's it for $1.09?
I better shut up then.
What's it for $1.99? Why do some angles sum to less than 180? We already explained that, and the picture that describes it is right there on the screen. When you get very small triangles, which you're down in the error band of the measurement to begin with. So it's quite possible and very expected that occasionally with small triangles, you're going to end up seeing something that looks like it's less than 180 degrees. It isn't. It is simply measurement error. That's all. That's why we don't care when you're looking at small areas, we don't care about spherical excess.
Well, it's not that just don't care. It's not observable. It has not. It is no longer entered into the observations because it's too small, as is described in planar surveys, which can be a couple of hundred square miles. Yeah, your X and Y values are not adversely affected by the shape of the Earth. However, elevations are still the same in geodetic and planar surveys because elevations are not part of planar surveys.
Oh, just in case people haven't realised, as you're coming in, you are coming in muted. Certainly, Rob, Carl, and Research Flat Moon, you're all muted. So
I didn't come in to talk. I came in to listen.
Likewise.
I don't
Fair
hear
enough.
a flat earther talking, though.
Well, no, because one won't come in here, will they?
Yeah, are you just reading stuff off of the chat?
Yeah, that's where because that's where Whitsitt is choosing to.
Oh, I always thought he loved to hear the sound of his own voice.
Yeah, okay, I'm gonna stop reading this silly thing. Got to spend some time and go through that in detail.
I've just stuck the link to the Discord in the live chat again, so Whitsitt can come and join if he wants to.
Oh, sure. We got Bob the
Good
Science
evening,
Guy
Rumpus.
and the Rumpus.
Welcome, the Rumpus.
Yes, I'm. Yes, I haven't been. I haven't seen all this presentation, so I've been. Oh, my life's been a bit busy over the last month. I hope it's all calmed down now, but unfortunately, I haven't been able to focus on things on the internet so much. But I did catch some of what was going on here, and I'm interested. This spherical excess has slightly confused me. I apologies if I haven't if I've missed part of Bill's Larry's presentation there. But if you're measuring spherical excess and you're measuring the azimuth between 2 points, and you can see the 2 points which you're measuring the azimuth between, then that means they're in a plane, and therefore there can't be any spherical excess. So, could someone sort me out?
The
The
Larry?
instrument at each location is oriented to the local vertical.
That's the problem.
So when you measure the angle between two other points, that you can see, yes, they're in the plane of your local horizontal. And at the other instrument, the angles are measured in the plane of that local horizontal. And for the third point, in its local horizontal. Those are three distinct planes. And that's why the angles, when you sum them up, exceed 180 degrees.
Oh, right. So
Yeah,
you're not
As-
measuring the angle, right, now I've got it. Right, so you're not measuring the angle in the plane of the points that you're looking at. You're measuring
Right.
the angle from the horizontal, right.
Yeah, because to orient your instrument such that the plate of the theodolite is in the plane of your two other observing points is nearly impossible.
Yeah,
There's
agreed.
uniformity. The standing axis of the theodolite is vertical at that location.
Of
And
course,
as we
yeah.
know, vertical is radial to the planet. And so vertical at point A, vertical at point B are divergent,
Yeah,
52 arc seconds per mile of separation.
got it. Yeah, yeah, good one. Yeah, I must admit I hadn't. Yes, I did sort of think that about some months ago, and then I had a conversation with some people,
And
flatties or something.
as Whitsitt has been, fairly, present in making his super chats, the question still stands. Does he think the spherical excess is overstated, understated, or non-existent?
Well, he's claiming, I saw one comment of his that some of the numbers are below, some of the triangles are below 180, and how do we account for that? And other people
Have you seen? Well, you need to see the graph. The graph where
this stuff here, yeah.
somebody else, I forget his name. His name is like Stark Oddly or something.
Stark
where he has
order, yeah.
plotted area of triangle and spherical excess, which is a fairly uniform 1 arc second per 72 square miles. So when you have a triangle that's only 72 square miles, that's 1 arc second of spherical excess. That's 1/3 of 1 arc second at each vertex. That is at the threshold. That is at the threshold of observation.
Right. What's the distance these circles? What was? So I missed some of the data. Apologies for missing the data here. But what's the distances that these observations were made across? What, a couple of 100 miles?
Some in the west do exceed 100 miles, and in the east they are typically a small portion of that, 10, 20, 30 miles, because they're in the east. When they get to the west, some of these triangles, some singular triangles have 3,500 or 2,500 square miles in a single triangle. In that case, the spherical excess is in the many tens of seconds. Now, the question is, these points still exist in the field. Go back out there and measure them today. Will you get the same angle as reported in the abstract? Or will it be some 20 arc seconds different? Because when you're in that large area triangle with, like I said, 40, 30, 50, 60 seconds of excess, that's 15, 20, 30 seconds per vertex. Now, 20 or 30 seconds, that's a long fucking way. And the question is, what would you get today if you went back and reobserved the same points in that report, and many, many of those points are still existent. So I don't know if he's complaining it's overstated, understated, or non-existent and fabricated. Because his measurement, when he won't go out and redo it, will return what's in the abstract, give or take very few, couple, 1, 2, 3 arc seconds most.
Yeah. So you can't make measurements 183 kilometers accurately, and even according to this PDF, a lot of the bigger triangles can't actually be observed, and you use the ellipsoid model. So what's up with that? Okay, crickets.
Well,
Next
no,
question.
tell me where does it say that?
I'm driving right now. I think it's page 18 mentions it. I can't really look at my phone. I'm driving. But anyway, so because like I'm not claiming to be an expert on this, but I'm seeing a lot. Yeah, but I'm seeing a lot of like flip-flopping and avoiding questions going on, which just makes me think that you're being suspect, right? So it's like when you guys claim that they just take an average. This is the narrative you guys paint, right? They go out onto the earth and then they just make raw data measurements. They write them down. They average them out. They write everything down that they take. They average it out, just an average, a raw average, and then they put it down as the observed angle. That's what you guys are claiming. And I'm asking, where does it say that? Can you cite where it says they do that? Or is that just a narrative that you guys made up and then repeated MC Tune over and over?
Well, if they say they observed something, that implies they observed it. I mean, I haven't read the document, so I'm not familiar. But if they, I mean, it says in this document like that I'm looking at here, that was posted, I think, by this is the one by Starcotter. It says observed excess plotted against triangle error, which means if it's observed, that means they must have measured it.
You guys remember when I said that it's just a whole bunch of avoiding the question going on? Yeah. So that's what that was. So
no, it wasn't. You said, where do they? It's like saying to if someone writes a paper, where does it state that they put the, some chemical in something? Well, if they say that this reaction occurred, it's implicit. I mean, if they had to describe it to the level you're saying that they will have described the procedure. If they say they observed something, that means they observed it. I mean, it's implicit in that statement.
Maybe you need to listen before.
Yeah, you need to listen to what I just said. You're getting confused by averages. You seem to think that taking an average is somehow unfair. Do you regard that as an unfair thing to do?
Buddy, can you please stop interrupting me?
Well, can you answer my question?
I already heard that you didn't understand that line of sight triangles
perfectly.
You didn't understand that line of sight triangles equal 180. You're not some arbiter of truth in this subject. Trust me. You didn't know that line of sight triangles equal 180.
No, they don't. That's the point. Did you not listen to my answer I got? You didn't understand my question, did you?
Oh
line
my
of
God.
sight.
Okay.
Let's try. I'm going to have to explain it to you.
I'm not in here to talk.
You didn't understand. You didn't understand the answer that Larry gave to me, did you? The fact that you've just made that statement means you didn't understand my question and you didn't understand the answer that Larry gave to me.
Okay, so this is what my actual question was. You guys are claiming that they take observed angles and then they make a raw average. They take a raw average and then they just write down the observed angle. Can you cite in the paper where it says they do that? Because the entire paper says they apply weighted equations based on a reference spheroid.
I can't find
that. That's the adjustment. Yeah, that's the adjustment phase that dealt with the measurements as reported. So they show input, they describe the adjustment, and an output. It isn't cyclic and go back and revise the input.
There's nothing in that paper that says.
How are they factoring what
there
the
is
input
nothing
is?
in the paper that says they applied any correction to the raw data to get raw data. You're asking for the logs of the surveyors where they mark down their individual measurements. Now, I don't know if that's part of the paper. Well, no, that's exactly what you're asking. You're asking for the raw measurements that were averaged.
No, it's not what I'm asking.
They did an adjustment on the 1866 ellipsoid. Yes, they did. But they didn't.
It's funny you guys are talking so big, but now you have to make sure I don't get to talk. Like, you guys are so the Flyers
You're
are
not
so
listening
scared
to
of
the
you.
answer. You haven't understood the answer, so people are giving you another.
He hasn't answered my question.
Yes,
Okay,
because
so
you haven't allowed him to do so, and you keep on
Why
claiming
don't
he's
you talk
interrupting you.
less and listen more and get the answer? What's it?
Yeah.
oh my
you get
God.
well, let people give you the answer.
Rumpus, you don't know the answer, so why are you talking?
I must admit, I'm not familiar with this document, so I don't know your citation.
Please,
and the
can you
correct,
let me
but
talk
Larry,
to the other
but
people?
Larry clearly does know the answer, and he's trying to give
So
you
you
the
shouldn't be
answer.
talking then,
Well,
right?
I'm getting you to shut up to let Larry talk.
Okay, so
maybe you should be quiet.
You're breaking up,
Somebody's
Earth's
roboting.
Life.
all right, man. So this is what I'm asking for. I know that we don't have like the raw. You keep saying raw data, but the actual raw data would be you just wrote down all your measurements and we would see everything that you got. That would be the raw data. Then we could go look at all the measurements they saw in the field. That would be the raw
No,
data.
they're going to give you the
Okay,
average. They're not
no,
going to give you.
admitted.
Oh my God,
Okay, admitted.
Rumpus.
Okay, admitted. They did not put in a photocopy of the field notes. They did not show the pen and ink work done in the field. True.
Okay, that's
But
fine.
they'd have
And
got
it's
the
all
average,
good.
though.
I'm moving past
Larry,
that.
they would have
I'm
put the
moving
average in,
past
though,
that.
wouldn't they? They'd
Oh
have
my
just simply averaged it, and then get that. That's the number you would get, surely.
They
Like, I got
presented-
like 10 minutes before I get to where I'm
they-
going, and if Rumpus is just going to interrupt the whole time,
No,
there's
yeah, you
really
didn't
no.
understand. You're misunderstanding what Larry's saying, because he said you're not getting the field notes. You're then jumping on that,
Can
and he's about to
you
explain.
stop
And he's
talking?
about to explain why you don't get the field note numbers, and instead you get an average of the field notes. I'm presuming that's what
I
Larry's
know
about to
that.
say.
I
Well,
know
then
that.
why did you ask such a stupid question then?
Well, if you would shut up, I'd be able to finish what I'm actually saying, huh? Okay, so I know that we don't have the raw field notes. I'm correcting the use of raw data as this gaslighting tactic. You guys say, oh, all the raw data is there. Why don't you guys just go check it yourself? The raw data isn't there, okay? Now what the contention is, okay, whether or not you have the raw data, which is like what the actual measurements they made, we know we don't have that, okay? So we can set that aside. Now, you guys are claiming they took all of those measurements, the actual raw data, and then made an average, and then they recorded the average as the observed angle. I'm asking you, where in the paper does it detail that that is the process of recording the observed angle?
So you want to know in the data that's presented in the paper whether it mentions it's an average or not. Okay.
Yeah, because it specifically says it's a weighted equation, and obviously weighted equations and raw averages are not the same thing.
Well, it also says they gave equal weight to all of them.
And that there are mistakes.
That's why they measured more than one time with it.
Oh, okay, but this is after they measured more than one time.
Do you not want to know what an average is?
Oh my God! Now we're back to just saying the word like somehow if you pretend I don't understand basic math,
No,
No,
then
you
you
don't
become
you
understand
do.
basic math.
the weighted equations are part of the adjustment phase.
They're not
Okay,
part
so
of the
then
raw
for
data.
one, so for one, you would agree that when MC Tune, because whenever I was asking him about how some of the angles are less than 180, and what his response was I'm like, what is this correction? He said the correction is where they take the averages and then the average is the correction. That's what he said. Now you guys are saying that the observed angle is an average. So you guys all agree that MC Tune was wrong when he said that, right?
That's not what MC said at all.
And
It literally is recorded.
The observed angle is from an observing session, which can involve 18 or 20 repetitions, and the singular value from those 18 observations at that station is brought forward, and the probable error of those observations and the accumulated standard error of those observations per station are the input. Yes, it is not the raw field notes. It is the product of the field notes. Now, they can take it back to, you want to take it back to, some anatomical origin. Yeah, I suppose you could go and if the field notes still exist, but those in the abstract, that is the angles from the station between the stations on the at the distant points.
Do you accept that's a reasonable thing to do? Do you accept that's a reasonable thing to do? Instead of presenting all the field notes of 30 or whatever, however, it's about 30. I mean, when the Ordnance Survey did something, they took 30 observations of each station in the UK. Yeah, shut up. Try listening. So do you accept it's a
I'm not
reasonable
here
thing
to
to do?
talk to you,
Be
dude.
quiet. Do you accept it's a reasonable thing to do to take 30 odd measurements and then put the average in the paper? Do you regard that as a reasonable thing to do?
Sure, but what's
Well,
unreasonable?
then why are you moaning about it?
Immediately interrupting, because you're an actual psychopath. You actually have no self-control.
Hang on. The answer may be in the side chat. MC Toon said,
and now it's the next ball.
Hang on. Whitsett, the weighted equations are applied to the corrections, not to the observed data, let alone the observed raw data.
He doesn't
That's
understand
what
that.
you.
That's
now
what
it's the next baller's turn. Why don't any flat earthers come in here? Because you don't let them talk and you circle jerk each other. That's
are you
why.
not talking right now? Are you not talking right now?
Why do you guys keep interrupting me? You all heard Rumpus.
Because it's fun. That's what.
Whining.
You heard Rumpus scream through me 2 words in, and then it was all your turn.
Because you were questioning
He's
the
doing
procedure.
It again.
Yeah,
He's
because you're questioning
Quit
a procedure
whining.
that's accepted as a valid thing to do. If
Okay,
you regard this as invalid, then you're questioning the way that science and surveying and almost any other gathering of data is done.
It's just not true, guys. You're wrong.
Okay, relax
I can
a
find
second.
it in the paper.
Okay, relax a second. Whitsett, are you saying that the spherical excess is overstated, understated, or non-existent?
It's baked in. So
okay,
this is the.
Is that understated, overstated, or non-existent?
It's created based on a spherical assumption. You take a spherical coordinate system, and that's how you even determine your location. You make corrections for sea level. You make corrections for zenith. Then you take azimuth readings, and then you use a weighted mean, like a bell curve, effectively. The least square.
And now answer the question.
Oh my God!
You're not answering the question.
No, let Whitsett go, please.
This is why you people suck.
Come on, guys.
Let Whitsett go.
Let Whitsett talk. Come on.
Okay, so and then you make additional corrections based on the reference spheroid, which is a certain ellipsoid model, right? Now, my point here is very simple. I just want to fact check it, okay? And I want you guys to show me where it says they just take an average. Because in current geodetic surveying, what they do, for example, they'll have a window, right? An accepted window. And if they make measurements and it falls outside that window, they disregard them as outliers, as errors. Now, I'm not even saying it's unreasonable. Say that you make 10 measurements and they're all 10 degrees, and then you make one measurement that's 20 degrees. Well, sure, it's reasonable to consider that an error, whatever. My point is that I want to know if they did that with this one, and what was the window? What's the window of accepted measurement? Do you guys know? Is it outlined or because? And the only reason I bring up the field note thing is because you guys keep on saying raw data as if to taunt the flat earthers. They have the raw data right there. You can check it yourself, but they don't have the raw data. So stop saying it. Stop saying that.
Just a second. But they also told you can go and verify it for yourself. Get the raw data yourself.
That's right. They said that. That's right.
And even in publishing of a white paper that doesn't include a photocopy of handwritten lab notes.
That's fine. My point is just stop saying that you have the raw data. Stop telling the flat earthers, just go look at the raw data. They put all the raw data there. They didn't do it. Like, no, they didn't.
Effectively, yes, it's an average of the raw data is as raw as you can accept. You can reasonably expect to be presented in a paper.
Wait,
okay, so
are you questioning the validity of the average?
Do you? Yeah,
Seems
that's
to
what
be.
I'm just asking to figure it out, and no one can answer.
That's why I asked him if he thought this was a reasonable thing to do, and he hasn't accepted that it is a reasonable thing to do. He seems to be questioning a basic, fundamental procedure.
Grow up.
You're telling me to grow up, and there's a grown man in here who can't control himself?
Yep. Yeah, you're the only one who can't control yourself. You seem to be questioning a very basic procedure that's used by basically all science and engineering. That's how you present it. You don't present every 30 measurements on one thing. You say this is the average we've got, and that's all that anybody's interested in.
Okay, now let's see if we can just reach a middle ground here. Do you guys agree that if before the observed angle is written down, that there is a spherical assumption of any kind applied? That
no.
In the abstract portion, there is no spherical excess applied to that portion in the abstract. the spherical excess, as observed by the summation of those triangles, is on the input side, and then they do have a Clark 1866 spherical excess a priori calculation and noting how close they are to each other. And that's why they pointed out the Clark ellipsoid fits better in the east, and the Bessel ellipsoid fits better in the west, which means the ellipsoid needs to be revised, not invented.
Okay, yeah, I had gotten a phone call, but my question is, do you guys agree that if they use spherical coordinates to transform your position and sea level, they're making spherical applications to everything that they run the observed angle?
None of that is in the data. This is you don't understand, do you? The average is just simply taking the azimuth and then
with the oh
taking
my
an
God
average.
Hold on.
You guys are wrong.
I'm not a little bitch. You guys aren't going to just talk over me every time I talk.
Because you're making a stupid point.
No, he's not. It's in the paper.
Let's keep it to a Discord, okay? Now,
okay,
as Bill pointed out, there's an output side of the adjustment that they did run against the 1866, and you have the input side, which in the abstract does not have spherical applied to it per station in the abstract. In the computation side, they do have the Clark 1866 calculated anticipated spherical excess, and they have the observed angles, which return nearly 1 second different in spherical excess, which is showing that A and B in flattening are not exactly correct. And that's why it's entitled Determining the Figure of Earth, and the output in the later section is listed as preliminary because the computation continued years after this.
Okay, my question was, do you agree that if when they take their observed angles, they actually throw some out based on a predetermined window of the spheroid model? Or I'm asking a question. Dude.
Yeah. So I let me try to wait. I think we have a problem. Do you know how you measure angles with it? Do you understand?
I'm not playing this game.
Wait, no, it is important. It is important.
I am 1
You
minute away
point.
from where I have to go.
Listen, listen with it.
Congratulations, you guys got no
Listen with it. I'm answering your question. You point.
I have to go.
Yeah, go away then.
You have to be quiet to hear the answer.
What you guys want to do is censor me talking, and then when I have to leave, be like,
I
"Oh,
heard
you
your
ran away.
question.
You got
I heard
destroyed."
your question. I'm trying to answer it.
I was in the middle of asking it.
You want us to
What are
answer
you
your
going to
questions,
ask?
but you won't answer our questions.
I believe
you want to be able. Whitson Owens wants to be able to control the conversation. That's
Right.
he wants to be able to control the
No,
conversation.
you guys are wrong.
You couldn't expect any better behavior from
Stop
grown-ass
talking,
men obsessed with
Whitson.
flat Earth
All
for
right,
7
guys,
years.
that's enough.
Yeah, it's
Calm
never.
down. Everybody calm down.
And Whitson had a very good question. Whitson had a very good question on the specifications for tolerances on accepted angle measurement. And I do not see that in there. But in the standard, the probable error as reported of any one measurement and the standard error of the array of measurements is returned. And I don't know if they took 30 and threw 10 out, or if they took 18 and used 18. Correct. That could be a point of investigation. What was the specification on acceptance or outlier determination?
No, but he's claiming that data that we present, we call the raw data, has been somehow manipulated to agree with spherical shape of the Earth. Let me finish, please. Sorry, Larry, just quickly there. But we're saying, no, all it's done is just a statistical operation is done on it. And you're saying that possibly outliers me, but that's only done on a statistical basis. Let's suppose what did that offer? Let's suppose you have 10 measurements that all within 1%, and then suddenly you've got one that's, say, twice as big as everything else. Then obviously you can argue that perhaps someone hit the instrument or something failed. That's where Larry's saying, well, what's the criteria for throwing it out? But the point is that what we're calling the raw data has not been processed by any spherical excess algorithm or manipulated. It's just simply taking numbers and averaging them. And that means there's no manipulation, there's no presumption of spherical shape of the Earth at all. So your whole point, which is your basis, which seems to be your argument, is that somehow this data has been manipulated to agree with the spherical Earth, and it hasn't.
I would say it probably has to do with a standard deviation.
And the point, And the points still exist in the field. If you go and remeasure them today, you will get the same angle that's reported in the abstract, give or take a tolerance. You're not going to get 20 seconds different. They did not add spherical excess in the field at the time of the angle measurement and report a measured angle plus a spherical excess. They just reported the measured angle. Now, yes, there is a little statistical measurement going on. That's metrology, because they did rotate the plate on the instrument and they did make many, many observations. And those many, many observations returned a probable error of about a second. Most of them have a probable error of 1 second, 0.9 seconds, some very small values. And given that it's like 16, 18 measurements, the standard error is reduced by the square root of the number of observations. All right, you're right. I don't have what constitutes a reobservation flag. I said these are too noisy. Redo. I don't know that.
Yeah, but he's doing more than that, Larry. He's claiming that those numbers have been manipulated, gone through some spherical excess algorithm.
I heard what he said.
They have, Rumpus.
No, they haven't. That's what Larry's. No, they haven't. They're just raw data.
In the paper. No,
I got it.
Wrong. Even the
Where does it
observed
say that
angles
in the paper?
have two different adjustments made to them before the corrections.
What?
So you're wrong.
They did make line of sight observations at 100 and 120 and 180 miles. That line of sight,
miles.
Yeah, that was observed optically, mountaintop to mountain.
Yeah, except that the super big triangles needed approximations to be made. The ones that went outside of line of sight. You guys need to read it.
The ones that went outside line of sight are not reported. They didn't see it. They didn't write. They didn't see it. They didn't measure.
Yeah, they did. They used approximation methods. I'll find the page and post it.
But it can't be an observed angle, can it? If he couldn't see it, then it's not an observed angle.
Oh, that's weird, huh? And they definitely have a spherical excess formula with the R value in it that they use to add it to it. So
not in the raw data.
It's not at the observation stage.
I know.
That is.
I don't care. Okay. If it happens after, they still did it. It's still not.
But we're arguing about the observed data register. We're not arguing about what happens afterwards.
It's two different things.
Whitsett's claim that the raw data has got some interference with it, some spherical excess added in. That's his claim.
No. It's got adjustments and changes made into it, but the spherical excess formula that they used for adjustments, I don't know where they did that. I don't know if they did that.
But it's not on the raw data register, which is what Whitsett is claiming.
Probably right.
The fact that you just said you don't know and come in and try to claim something is fine.
It's not in the abstract of angles.
The intro? What are you talking about?
No, you came in. Sorry.
Yeah, the abstract, as exampled on page 556, does not have the angles added. Nothing is added to the angles for spherical excess. The only thing dealing with the angles as reported in the abstract.
Was that the East Coast? Because the only ones that didn't is the East Coast ones.
The East Coast ones are very small triangles. Okay, and very small triangles have a different.
And they still did it. They reduced it by a third, and then they distributed the spherical excess over the three angles unevenly.
Wait, so you're saying they added the spherical excess just to make it look like they were spherical triangles?
Not in the abstract, but in the adjustment. Yeah,
I don't care if it's in the input or the output. They did it, so it says.
Okay, in the output, that's fine. Yeah, the output. They did make it. They did make an adjustment
across the country and turn them into an arc.
Yeah, they did make an adjustment on the Clark 1866 ellipsoid. That is a well-known ellipsoid. They were not out there to discover if the Earth is ellipsoidal. They went out there to further refine the dimensions of the ellipsoid.
Oh, then maybe it shouldn't be used as globe proof, huh? You agree? Yeah, thank you.
No, we don't.
Jesus Christ. We're talking about the big triangles. Forget the small ones, okay?
You guys need to read it. That's all.
Don't need to read anything. Take one big triangle, and that's
totally
it.
off your bunch of clowns.
Hey, can I ask a question? Hey, Regis, how long have you worked as a geodetic surveyor?
Hey, Larry, just out of curiosity, did they add a correction from the existing ellipsoid, or did they use the raw data to find corrections to the ellipsoid?
Yeah, by this survey, they were looking to refine the ellipsoid.
Okay, so they didn't take data from the ellipsoid and make a correction. They took data from the triangles and corrected the ellipsoid.
Yes, and by this survey, they did not publish a new ellipsoid, and that's why the output is labeled preliminary, and they worked on it for another 20 years. As is labeled, determining the figure of the Earth. They're looking to refine, and that's why the existing ellipsoids, Bessel and Clark, yes, they're well known. They weren't looking to like discover them or disprove them. They were looking to refine them. And they said they noted a lower residual in the west against Bessel and a lower residual in the east against Clark. And they said the ultimate ellipsoid of the North American datum may be defined by values intermediate to those two A and B and flattening tables.
Well, I guess it just goes to show that reading the words is the easy part. Understanding what the words say takes a little more effort. Because I got that immediately, and they seem to be confused about it.
Right.
Well, it's titled "Determining the Figure of Earth." Yeah, but they're starting from known characteristic of the ellipsoid of the planet, which was known for 2 centuries prior. Or a century prior, 1760, 1780, with the meridian surveys of the Academy of Sciences. Yeah, the ellipsoidal shape, that was already known, and they were refining the A and B and flattening values.
I guess the title would have been the big hint that they should have gotten, right?
Yeah, this is the presentation of a monumental piece of work, and they want to take it back to the subatomic by looking at photocopies of the field notes so that they can reevaluate the statistical analysis on taking 18 measurements using a direct and reverse with a theodolite with different plate measurements, different plate settings, and coming up with that to be the circle of angles from that station. What they did not do is then modify that with spherical excess. It's the plate reading.
Larry, what they're trying to do is nothing of the sort. What they're trying to do is they're trying to find anything that they can hang their hat on to deny the reality of this evidence. That's all they're doing. They're trying to find something to raise doubt.
Yeah,
so far unsuccessfully.
The question I have is are they saying spherical excess is overstated, understated, or non-existent?
Yeah, well, Whitsitt effectively said it was inserted into the data. He's saying that we do not have the raw data, and the spherical excess was inserted into it before as the input in that paper. Because he doesn't understand that it's a simple statistical process, because he's trying to conflate this idea of throwing out stuff that you would statistically reject with stuff that you're rejecting because it's not spherical. And so he's trying to conflate those two operations to confuse and muddy the water, and therefore rejecting a procedure that is used throughout of just how you would get averages. And that's any scientific paper is going to present the averages for something and not some 30 measurements of the same thing and just say, well, this is the average that I got, and then okay, I may have applied some statistical throwing out something that's some rogue figure, an outlier, but then that's the procedure that Larry said he didn't know they used. But I think we can assume that that's something that's assumed, I think, professionally, that these people know how to do that, and the averages they're going to present are going to represent the measurements that they have made.
Yeah, they're not trying to pull the smoke over somebody. They're not trying to invent something. Yeah, if they made 20 measurements, 20 roundings, sometimes called roundings, of turning the circle across all the other points, if they did that 20 times and one of them is noisy, that would be a flag for rejection or reobservation. Yeah, that does happen. But I don't know the threshold if that's like 1.6 or 2.0, arc seconds as a standard deviation. That is something I didn't see stated in here. It might very well be in there, but it's going to be a rigorous number, and it's not going to cause a rejection of 60% of the data.
And of
or
course, as you
have.
pointed out, this has been confirmed by subsequent observations and previous ones, so we know that this data is valid.
Yes,
the point
and
is,
in many cases, in there they show two different angles, one measured in 1875 and one measured in 1890, that may have significant discrepancy. Yeah, several arc seconds, and that's drawing a flag. Yeah, this is very fine measurement. And again, is it overstated, curvature or spherical excess, or understated or completely invented? Now,
Well,
the South Pole,
Whittier was claimed is completely invented. He's claimed the raw data is not raw. It does not represent the field notes. That's his point. Is it is created.
All right. So I'm back. Like, I will say this though, I am not talking if Rumpus is going to incessantly interrupt. But so this is what I want. Okay, so I have a page. Where can I drop a screenshot from the thing? Is there a chat or something?
Yeah, there is. Live chat.
Live chat.
It's the top one.
Okay, I got it. Okay, I'm trying to understand. I haven't really even read through all this. So this guy clearly seems to know about this. So can you explain to me?
Then maybe you shouldn't assert things if you don't really know much
What
about
did I
it.
assert? What did I assert?
Maybe refer to people who've been doing this for 30 or 40 years.
well, he didn't assert. Hold on. He didn't assert. He asked a question, which the answer to was very simple: no.
Well, actually,
any word beyond the no only create confusion. The answer is no. No assumption of any sphere was made for these observations. Those
now that's a cool
angle
story.
measurement.
Now,
That's a cool story. Yes, that's the story.
Yeah. So will you read this? Will the guy that knows?
No, how
about
about you read it first, Whitsitt, and tell us why you think you object to it.
I'm driving.
Don't post it until you've had a chance to review it, so you don't look foolish
I've
again.
read through parts of it, so someone just explain it to me.
I'm reading it. Stand by. I'm reading it. We can get back to you if you can hang for a couple of minutes.
Okay, because this is saying it uses the Clark's method or something. Like I said, good.
It's a good footnote. It's a good footnote. This is additive to the Discord. This is good. This is fine.
Yeah. Because, like I said, I'm not really claiming to know what all has happened with it. My point is that for example, when I went in and I talked to MC Toon, and no matter what someone in here jumps in and says he did or didn't say, I don't lie. Okay. So what he said was, whenever I'm like, well, what's up with these corrections? He said that the corrections were just, they take the observed angles, average them out. He even pulled up a graph to show the points. He said, and I quote, they either pick out a point or they average them out, but they normally average them out. That's what he said, quote unquote. And
all right, let me go ahead and correct that. What MC Toon said was that when you have several points coming into the same point where you're looking at azimuths to different points, they come back not to a single point, but to a small cluster of points.
Okay, that's not my point. My point
that is exactly your point, and that was what MC Toon said, because I went over it with him.
Tell me what my point is.
Easily.
But you're wrong every time. Okay,
do you know
so I'm
what
gonna try
your
to
point
finish.
is?
Please. Can we be cordial and act like adults? That'd be great. Okay, so I just now said I don't know about it. I am being thoroughly honest. Now, this is the point, though. Whenever I was talking to MC Toon, because what we found out was a lot of these, there's like over 20 or 30 that equal less than 180 or at 180. And what people say is that, well, it's margin of error. Well, it seems to lay out that the margin of error is about a degree. So if we're taking an average, what is the margin of error?
It's not a degree. I can assure you that,
it?
Larry.
It's on the order of it's sub-arc second. What's it?
Yeah, exactly.
Okay. Okay, that's even worse. So
that's even worse. Do you know what an arc second is?
Dude, you see how conversation is impossible with you guys?
Yeah, because
you know what an arc second is if you think that it's worse than a degree.
No, that's not what you don't know my point, so you don't know why it would be worse.
The first order screening of the data would be the standard deviation amongst the whole set, and that would be in this era of 1890 or so would be on the order of 2 arc seconds before a reobservation flag would be raised. Maybe
Okay.
three arc seconds as a standard deviation, which is why it is repeated 18, 16,
Okay.
sometimes 20 times.
Cool. Yeah. Yeah. So by the way, an anti-flat earther is the one that told me the degree thing. I don't know. Because like I've been traveling and I just got back. I haven't really got to look through it. It's 900 pages. But this is the point, okay? You guys are claiming that the observed angle. Now, originally, MC Toon said that they just write down the raw data. They take the angle, they write it down, and then they average it out, or they find. Why are you interrupt every? You guys are afraid to hear my point.
No, because I mean, obviously in the field notes, that's what they do, and then they average.
Rumpus, just let him finish, Rumpus, please, so he can stop crying. Go ahead, Witsit.
So when I was asking about the observed angle and then the adjustment, he said that the correction was that they take the average of all the observed angles and they use this intersection method, and then they make the correction with that. They take the average, and that's what the correction is. That the whatever that means, but that just doesn't make any sense, obviously, right?
Which is exactly what I said, Austin.
That obviously doesn't make any sense, right? Because there's one observed angle that's documented. That you don't take an average of one angle, and the correction isn't. It's a spherical excess formula. It isn't just taking raw data and taking an average. Now your argument
is. That's exactly what the input data is, and you keep on trying to claim that it's being processed in some way with some spherical excess correction, and it hasn't, and your claim is completely baseless.
Dude, my guy, you've got to stop, dude.
You've got to stop making these outrageous claims and repeating them. You've been told about 4 times now that the claim that you're making, that the spherical excess data somehow or algorithm has been somehow input into the original data, and it has not. And you keep on making this claim. You did. You said a correction had been applied. You just said that a correction had been applied, and then you've claimed the veracity of the raw data. And all we've told you is it's just an average. And you keep on claiming that it's more than just an average, that it's been corrected in some way, and it hasn't.
Okay.
Let him respond to you. That's all he's doing is responding to you.
No, he's interrupting me, straw manning what I said.
Then just stop talking and let him respond.
Just let him straw man me.
Go ahead, Witsit. I made my point. Go ahead.
Shut up! Okay, so the point is, what I actually said was that the correction uses a spherical excess formula. Okay? So
but that's not applied to the input data.
What is a spherical excess formula?
I never said it was!
You did. You claimed that the raw data was not just the average. You claimed it had a spherical excess correction.
Calm down, Austin. A little maturity,
calm down.
please.
They won't even let me say 5 words in a row.
Austin, I just told you exactly what you said, and you said I was wrong, and then proceeded to tell me exactly what I told you.
I would have been done 5 minutes ago.
You would have been done an hour ago if you'd stopped interrupting people.
I'm not the one interrupting. Okay, so this is the point. Okay, McToon said that the correction was just taking the average of the observed. I know that. Can you stop?
Okay, so McToon, you misunderstood him. Exactly. So you probably misunderstood him.
Okay, no. You want to bet $5,000 on it? Hey, you want to bet $5,000, Bob? Let's bet $5,000. You want to bet $5,000 on it?
Anytime you want, Austin.
You want to bet
$5,000? Put it in
escrow,
sign a contract.
Wait, no.
I guarantee you misunderstood what he said. I guarantee you misunderstood what he said.
Wait up, calm down. Do you want to bet $5,000 McToon did say that?
Let's go ahead and write up a contract and put the money in escrow, and we'll bet.
I just want to ask Witsit the question. What does it matter what McToon said? You have
I agree.
You have the expert here. Ask him. Don't ask McToon.
Perfect, man. Okay. What I'm saying is, what I was explaining is, I'm not claiming to be an expert, and I've been traveling. I haven't had a look at it all, and it's 900 pages. I am happy to talk to the guy. I can see that he clearly knows much more about it than I do. I said that. You guys are just combative old men obsessed with flat earth, so you have to fight. So my point is that, of course, when he said that, that's wrong. The correction actually uses a spherical excess formula. Now, the real debate boils down to the observed angle. Are the observed angles just genuine, exactly what they see? They write down, do they take an average and write it down with no bias? I know that's what you're claiming. Okay, so the point is that I want you guys to show me where it says that, because it says it uses the Bessel method, right? The Bessel method and the Clark method. Okay, when I go look at the paper Clark wrote, he specifically explains that your observed angles are literally run through spherical assumptions, and that it's a justifiable assumption because we can look at a boat from the surface and then go to a mountain and look at a boat, and that proves the Earth's an ellipsoid. That's what Clark said. So when this paper says that it's run through the Clark method, well, I went to Clark, and what he said was that you run it through spherical assumptions based on the justified nature of seeing a boat disappear from the mountain. Okay? So you guys are claiming it's just an average. I'm like, okay, can you cite in the paper where it says that there's no window, they don't disregard certain measurements, and they just take a raw-based average that
Again, you're conflating two things. You're conflating a statistical rejection of data, which has no understanding of the data being anything to do with the Earth, and then you're trying to slip in the idea of a correction that's to do with the spherical excess. And it's just, I mean, I don't know whether you're doing this deliberately or don't know what you're doing, or you're just a moron. But either way, you're being either dishonest or a moron.
You know what the Clark method is, Rumpus?
No, I don't.
Okay, so why are you telling me I'm a moron?
Because you are claiming that the raw data has had some spherical excess applied to it, and we're telling you it has not.
That's what Clark says.
Where did he say that?
In his paperwork explaining geodesy and how he used a method to determine the Clark ellipsoid.
Yes, but that's different from the raw data that's in the document that we're discussing.
No, he says when you take your raw documents, you have to apply this method.
Well, why is there a spherical excess at all? There shouldn't be any spherical excess.
See, they just run away.
He's claiming it's invented, Earth is life. He's claiming
that's the question. Like, why is there spherical excess at all?
Because
he's claiming there isn't Earth is life. He's saying it's been inserted.
They're using the Clark method. It says in their own paperwork that they used the Clark method.
If it's a planar triangle, there shouldn't be any spherical excess at all.
Yeah, but Earth is life. He's claiming it's been inserted into the data.
I know.
So why do you keep on asking the question? He's saying that this data is invalid data. He's saying it's not reflecting the genuine observations that were made.
And to clarify,
so why
what
do you
I'm
think
saying,
they just
I'm actually
inserted
being
it?
inquisitive. Okay, I'm actually being inquisitive. I am openly stating that I don't know all about this.
So why are you arguing this then if you don't know?
Because the reason it turns into this like, oh, with it saying this and this big fight, because if I ask questions and you guys refuse to answer them, you pretend I'm making claims. In reality,
the thing is,
this is
the questions
claim.
are being answered.
This is your
the
claim.
Questions are being answered, and you keep asking more and more questions. They're
Okay,
being
what's
answered.
the Clark's method?
You have someone here who has over 30 years of experience doing this, and yet you're still asking questions.
Yeah, what's
and
Clark's
explaining
method
it to
then?
me.
What's Clark's method? What's
I don't
Clark's
know.
method then?
I don't know.
Okay,
maybe you should be quiet and someone will answer that for you.
Yeah, Larry, what's this Clark's method? Do you know what it is? Oh, okay, it doesn't.
This is going to get so embarrassed.
Hold on.
In reading that, I wasn't clear if they're describing of a single occupation and returning the angles, or the adjustment process taking the host of angles in a triangulation. But
fair enough.
In my experience, you write down the angles as returned from the instrument, and standard deviations are observed, and if one exceeds a predescribed value, that's a flag for reobservation, not just discarding.
All right. Do you agree
that's the standard procedure that surveyors use? He's describing to you what the standard procedure that surveyors use. So that's why it doesn't. So that's why it doesn't explicitly say. It's implied. It's understood that that's what they do in these observations.
What makes you think I need you to mediate the conversation?
Because you don't understand what's being said. You seem to be saying that some other procedure is done, and Larry has just described to you the standard procedure, which would obviously also be followed in this observation and this paper, and you're challenging that.
You're so desperate. So
I see you're going to completely ignore my point. The standard procedure.
How can you say I'm ignoring it? If every
you
time
are,
I go
because
to respond,
Larry's just pointed you out what the standard procedure, and you keep on asking, where does it say in this document that's what they do?
I didn't even get to respond to him.
Hold on, that's the question you keep on asking. That's your basic question, actually. And Larry's told you that what the standard procedure is, and it does not, and it's implicit. Even if it's not explicit in the document, it's implicit because that's what surveyors do.
Okay, first of all, surveying has evolved significantly since this time. In fact, I know you haven't even read the paper. And
Larry will tell you otherwise. He says that they got accurate information hundreds of years ago, and they had established procedures that have worked for hundreds of years. And Larry will back me up on that, I hope.
Why is it that you think it's acceptable in conversation to incessantly interrupt?
Because you're not clarifying your point. Larry, you're claiming that surveyors do not use this particular procedure. That's your basic point.
I didn't say
You're
anything.
saying
I never
they're
said
using
that.
some other procedure. Larry's told you they don't, and so then you're stuck and you're not accepting the answer you're being given.
I wasn't even allowed to respond to Larry because you're a psycho and had to jump in and talk.
So there you are. You're just going to ignore the point again. Well done.
I'm trying to respond to the point for 5 minutes now. So you know that me and the Larry guy would have a very informative, intellectual conversation back and forth. But you're here just shitting on the table.
You're just diverting because you don't like what's being told to you. Larry told you what surveyors do.
Let me ask you a quick question, please. Larry?
Yeah?
Let me ask you a quick question. When you do azimuths from a single point, and then you do azimuths from those points back to the origin, do you always get a single point, or do you get a series of locations that are very close but scattered around that point?
Of course, the latter.
Okay. How do you address that? How do you address that?
In performing a least square simultaneous adjustment, many observations to a single point by identification of a single point, yes, will return a confidence region of probability. And the whole point of the least squares is to apply the smallest amount of residual or correction to the observed measurements, such that a strong figure with solid, very bold angles will come together, and you could individually compute all three of those vectors and end up with points falling something smaller than a manhole at some miles distance. But in a least square adjustment, it's taken simultaneous to where the smallest possible residual as the root of the mean square error is applied to come to singularity, and that's the simultaneous equation. So the software doesn't produce 8 points; it produces 1 point with a confidence region, and as the data is noisier, the confidence region inflates. So when I produce a point,
is one of the goals there to have 360 degrees on your azimuths from that point? No more, no less?
You're just asking questions you've heard MC Toon explain as if you're you're being genuine. You're not. You're just asking tactical questions.
How about we let Larry answer the question that I asked him, which I think was an appropriate question. Unless you disagree,
so when you guys ask why don't flat earthers come on here, what you meant was if a flat earther comes on here, we're going to make sure he doesn't get to talk or ask his questions, and then we're going to circle jerk.
You're interrupting a conversation between Larry and Bob, and you
shouldn't even be allowed to say the word.
So they shouldn't be allowed to have that conversation. Good one. I like it.
No, I was trying
Larry,
to respond to Larry
a valid
10
question
minutes ago.
you care to address?
360 degrees of azimuth at any one point. That's kind of ill-formed. If you have an array of angles from a single point, and you have a redundant network, and the angles then a residual to any one measured angle could be 3 or 4 seconds plus, 4 seconds minus, and when you take the final angle after a residual is identified, input data not changed, after a residual is identified, those angles will still add up to 360 degrees. Yes.
Okay, so that's exactly what MC Toon was talking about when he was talking to Whitsitt.
Okay, that's not the point.
Because intermediate, yes, one angle could be 51 degrees, the next one is going to be 87 degrees, and the adjustment for the residuals, one might be adjusted clockwise, a small amount, the other one could be adjusted counterclockwise, a small amount, because it has to come up with a simultaneous singular position of any one unique point. You don't end up with 5 points near each other. You have 1 point, and the smallest possible adjustment to the data in aggregate in one simultaneous observational equation.
Okay, but see, this is
Thank you, Larry.
yeah, but what MC Toon said was he invoked this idea to explain the corrections they made, right? The corrected angle. When in reality, that is not correct. Okay, so that's what he was saying. Now, what he could have more accurately said, he could have claimed that that's the method they used to write down the observed angle. Correct?
Well, you've misunderstood him. We apparently you've misunderstood what he said.
To be fair, MC Toon may have spoken a bit casually. He didn't take the deepest dive into the whole science. But it's
okay, but no, I specifically asked him point blank, what is the corrected angle? What is the correction? And that was his answer.
That's the residual, which would be in my circumstances, usually 1 or 2 arc seconds, of residual from what the angle I entered, the angle that is ultimately used in computation in a redundant scenario where 3, 5, 6 observations of a single distant point returns a single value, and the residual of any one of the observations could be clockwise a few seconds, could be counterclockwise a few seconds. And by taking the square of the residual and adding those up, you'll see that the square of the residual, instead of 2 seconds, the square there'll be 4, and you'll see 4, 5, 6, 7. You might see one that's like 10. Well, that is an outlier, and that gets de-weighted and may not even affect the overall adjustment, except in the confidence region may be slightly inflated. So one has to be very careful so as to not over filter and have angle data for the distance or angles that's less than 3 standard deviations outside the a priori global weighting gets included. So
okay.
Yeah, sometimes some shabby measurements are not shabby enough to be rejected.
Okay, so when I asked him what's the corrected angle, what's the correction, and he described the process of the interference method or whatever, like he was wrong. Okay, but it doesn't matter. That doesn't mean that you're wrong. So I'm trying to move on. Okay, like if he didn't take the bet, smart man, you would owe me $5,000. So anyway, now what it's turned into is the observed angle is just based on raw data. They take an average. Now I talked to a surveyor a couple years ago. You guys know him, main surveyor, right? He told me point blank that what you have a window of accepted measurements, and you said de-weighted. He said that they just disregard. He personally disregards them if they're outliers. Okay, that's what he said. Now, I would find it hard to believe they didn't do this here. But either way, like I'm trying to figure out if it says that they start off by using the Clark method to get their observed angle and to make their direction adjustments, and they apply spherical coordinates to their location.
No, they don't.
And
you're making that up.
Yeah, I just dropped where it says it.
Okay, now when taking these data and adjusting, and you have a highly redundant data set, one needs to be very careful about over filtering, without a doubt. And depending on how much redundancy you have, the least square adjustment will take care of itself. And generally,
Larry, you're not tackling his point.
Larry,
he's claiming that this Clark procedure is inserting spherical excess. And you need to tackle that.
Generally, you have a threshold of about 3 standard deviations before a flag is inserted. And in this 1900 report, there are some asterisks of observations not included, and they're damn few, but they're still
Larry, you're missing the point, Larry. The point is he's claiming this Clark procedure, whatever it is inserting spherical excess into the data, and he doesn't believe it's just a statistical thing that you're talking about. So you're not answering his question.
He said he needs to look into the Clark method, which I think you do, because I went and started reading through that as well. But there's a lot of information. The Clark paperwork is a huge document. This is 900 pages as well. That's why I know that you probably know more than all the other Globers, but you haven't read the whole thing. And that 99% of these anti-flat earthers that pretend they know all about it don't know shit about it. Okay,
You know
so
nothing
that's
about anything, so you're supremely
my
ignorant.
point is it says it runs through the Clark method. It says use a spherical coordinate system, but like before you even make your measurements, you determine your positioning, your location based on spherical coordinates using astronomical coordinates. Okay, that's what it says, astronomical latitude. And then what it says at the beginning of this document is it explains that they've been correct, like updating different surveying methods, and this is built upon other surveying data. A lot of it's built upon assumed data from the other surveys. And then it says that this is the first time that they used a latitude correction, a spherical latitude correction in this survey. That's what it says.
I don't believe that will not be in the raw data.
Okay, yeah, that's in the adjustment process.
Exactly. This is the point you've been making repeatedly. You're conflating the corrections with what they do with the raw data, and you're trying to present it as though the raw data's had this applied to it, and it hasn't.
Wait. How is it when we're about to make an observation and we're determining our location, right? So that's before adjustment. We're determining our location before adjustment. Okay. We use a spherical
location. The data is the angle, the azimuth that they measure between 2 points. That's the data, and then that's averaged. Then the position about where there's another issue. The point is the data that's averaged is just the data being averaged, and then you're claiming this data's had all sorts of spherical excess inserted in it, and it hasn't.
No,
you're just making it
not
up.
my claim. It
is your claim. You're claiming this Clark method is introducing spherical excess effects into the raw data that's been measured and averaged. Yes, you are.
No. First of all,
yes.
What? No. Okay. What I actually am, my current understanding, which I'm certainly open to being wrong, is that the observed angle is actually run through a weighted equation. So you take your angles, you have like your predetermined window based on your spherical coordinate system, and
no, it's not based on spherical coordinates.
Can you
it's
please
just data.
stop?
You've just made something up. It's just simply data. The measurement of azimuth is just simply a thing you record from the instrument. And then they make 30 measurements of it, and then they do averaging on it. No part of that is involved in messing around with spherical excess or spherical coordinates.
Wow.
Don't they? I have a question. Don't they just write down the observation?
Yeah, I bet.
Right?
No. Oh,
don't they just write it down?
No.
Yeah, but they don't put that in the paper, Brenda. They then average that, and that's the information they put in the paper would be an average of, say, 20 or 30 measurements. So they don't actually use that data in the paper.
That's what you guys say.
So the point is, you keep on trying this trick, of claiming that there's some adjustment that's been inserted into the raw data, and it has not been. That's a subsequent adjustment to do with position things. It's not to do with the observation of the azimuth.
Can you guys hear me? Can you guys hear me?
Yeah. I'm trying.
So what they do is
there we go. Whatever we do, don't let Witsit make his point. Whatever we do, then the Earth will be a ball.
Harder. I just want to clarify. They make multiple observations, take an average, and then that's written down. Is that correct?
Correct. That's what.
Cite it.
Well,
Larry described the procedure to you earlier. Sorry, Brandon, to interrupt you. Larry described how surveyors do this, and so you rejected. And when I pointed this out, you wanted to evade that point repeatedly. Larry pointed out to you how surveyors do it, and you didn't want to accept it.
No, listen, this is the problem, okay? If every time I'm making a point, you guys have to say, Larry, what about this?
You've ignored Larry's description of the procedure, and and then you come up with some excuse for not understanding what Larry told you, and it's implicit in the procedures that is used in this surveying.
Are you guys actually confused why flat earthers don't come here? Because it would be because people like Rumpus are here and they don't let you talk.
You don't listen to the answers, do you?
I can't even finish my point ever. So if every time I have to make a point, you have to turn around and say, Larry, what about this and that? Maybe you should just let me talk to him.
Like we did, but you didn't listen to what he told you. You keep on asking, where's it written down in the paper that they just averaged the data? Larry pointed out to you what the procedure is. Now, I haven't read the paper, so I don't know if they do explicitly, but if they don't, then it's implicit in what Larry was saying is the procedure they've used for hundreds of years to do this, and you seem to be questioning that.
Dude, you haven't read the paper, and you got this much of.
But I've got Larry here who tells you what the procedure is, and and they've done the same way for hundreds of years.
Let me talk to him, dude.
But you didn't listen to his answers, did
You
you?
have such an ego, man.
You didn't
just have
listen
to be the one talking
to
like you know what
his answer, did you?
I was literally in the middle of explaining my current understanding, and I was going to ask Larry to correct me if I'm wrong about something.
About 10 times you've said they've used the Clark method to insert spherical excess in data. You've been told by Larry and other people about 10 times that's not what they did.
Okay. So first of all, whenever I brought up Clark's method, he specifically said he didn't know about it. Okay. So he didn't say anything. Secondly, stop saying I'm claiming that they input spherical excess. I'm trying to explain what I actually said. Okay. So from my current understanding is you have a predetermined window based on your spherical coordinate systems, right?
No,
and
you made it up. Well, you're wrong.
Interrupting me.
Rumpus, lay off. Rumpus, lay off.
So you take a weighted mean, you apply weights based on, you have a predicted value based on that location, and then you apply weights to however close you are to the predicted value. And then you get your mean, what you guys are calling the average, okay? And then
there is no predicted value. Your whole basis, your thing. Yeah, but come on, he can't get away with this. He keeps on saying the same thing.
Stop.
Make a cuppa.
I'm just saying, I'm open to Larry correcting me. Not you, though. You've shown you don't know.
I don't think you are open to Larry correcting
No,
you.
you keep on making this claim about predicted. There's nothing predicted about this. This is just data, and then they do a statistical thing
Okay,
to check.
Rumpus, we got it. Rumpus.
Well, he hasn't, though. He has not accepted that. He keeps on talking about predicted data.
Rumpus.
Yeah, I just have a short question to Widget. Are you trying to exhaust us, Widget? Is that the purpose? You will keep asking the same question again and again until we're exhausted.
Oh my God, you people are unbearable.
Here's an example. I go out into the field and I set up my theodolite over a mark and I read the angle across 5 other distant marks. I have no idea of the coordinate I am on. I have no idea of the azimuth in any one direction. I measure it 16 times. I go through the individual angles as subtracted out, see that the noise level is sufficiently low as indicated in the screenshot I just put up there. So the standard deviation of my angles. At that point, I am done with the field data. Those angles then are put into the adjustment process. It doesn't change what I wrote down on the field notes.
Okay.
I don't have any a priori information about anything about the sphere, the azimuth, or nothing. In the adjustment process, you can adjust that against the Bessel or the Clark or the WGS84. That's independent of what occurred in the field.
Okay, so what is used to determine the weight distribution?
That is in the adjustment process. That's very complicated least square simultaneous piece of calculus. Okay, so if you get a measurement that's way off, what do you do with it? You write it down and average it in? That's what you're saying? No. If it is more than 3 standard deviations out, then it gets flagged for reobservation, or if the endeavor is redundant enough to live without it.
He's told you that about 10 times. He's made that same statement 10 times. When you keep on asking, what do they do with some outlier? And Larry's told you 10 times how it's red flagged as a reobservation, and you don't listen to the answer.
Can we let?
It never says anything of value, ever. It is highly dependent. 3 standard deviations off of what? 3 standard deviations from what? From the instrument resolution. So if you have a 1-second instrument, when you see angles that are returning 3 and 4-second noise values, then that gets flagged. And there's maybe you either find out what went wrong, maybe it was weather conditions, maybe it was just, operator inexperience. But it all comes down to the strength of figures and your degrees of freedom on whether or not you can just live without it or it gets reobserved. Okay, so how are you determining if it's like weather or something? Like what I'm saying is, if you're just taking raw measurements and you take the measurements and it shows you something that's drastically off of what? Drastically off of what? What's your standard of comparison to determine that it's drastically off?
It's very simple, Whitsit. If you understood statistics, you have, in other words, the distribution of your values is great.
Let Larry Rumpus.
The repeat measurements. That's why we take 16 or 18 at a time, or 12 or 6 at a time. And the overall noise level of those angles, real time, figured, with just a basic calculator. Now, if in the office those angles don't fit, then there's another problem, which is either sent back for reobservation, or if it's redundant enough to omit. But that is in the rare. If you do that to more than 5% of your measurements, you have a very real fucking problem. But if you have one or two in a large array, very different situation.
Yeah, Larry, what he doesn't understand is that there's not a value you're trying to achieve. He doesn't understand the Bell distribution and that whether or not your Bell is big or small. And he thinks you've got a target value and whether you're missing it by something. He doesn't understand that just raw data can have a distribution.
That's what the Clark method
there
is.
Are targets. No, there are targets, and that has to do with order and class of the survey. If you're doing a second order class survey, then you have tolerances of a few arc seconds.
Yeah, but Larry, that's the tolerance. He's talking about there's some value you're trying to achieve. He doesn't understand that it's the tolerance that you're talking about.
Okay, can I maybe just finish my point? So obviously the spherical excess formula is not synonymous with the weighted equation. These are not the same thing. So you're saying
got nothing to do with one another.
You shut up. So
you keep on trying to conflate the two. You keep on trying to claim that the spherical excess is included in the statistical analysis. And we've got to point out that this is what he's doing. He keeps on. Hold on, I've got to make this point. He keeps on trying to conflate a statistical process with the spherical excess inclusion, and we keep on telling him this is not happening, and he keeps on claiming it is.
Can we please
I literally just stated.
Can we please let Larry and Wissett talk?
So I literally just stated that they're different. He jumped in to say, I keep saying they're the same. Okay, so obviously they're different. You have the spherical excess formula, you have the weighted equation. So I'm asking you point blank, are you claiming that both of those are applied in the adjustment?
In the adjustment? Yeah, because you are generating your coordinates against the ellipsoid. So yes, spherical excess is observed and measured and compared against the ellipsoid, and residuals are exposed. And residuals, have a specification, and given their degrees of freedom and the order and class of work you're trying to accomplish, you may have to increase redundancy or you may have to make some reobservations.
Okay, so I'm asking you in this specific survey, because unless you want to show me where you've done like huge distances and we can go verify it and do it with you or something, I don't care at all about like you looking 20 miles or something. So whenever like I want to know in this survey, right, you guys keep claiming that they just took a raw average, right? And first of all, you guys keep saying it sounds good. Oh, all the raw data is there, they're not hiding anything, and you can go do it yourself, and they just took an average. So it's like to the viewer, you can just go to the PDF, look at all the raw measurements from the field, take a raw average, and show that they got the right observed angle. Now, that's not the case. We know that those angles are not there. So what I'm asking is, why is it that you guys are stating that it's just a raw average, and where are you getting that information? Because the entire paper talks about weighted equations.
And because the bulk of the paper talks about the adjustment of the raw data. And the raw data, as described in the abstract, does not include the pen and paper ink. True, but it did pass a QC evaluation before it was included or flagged for reobservation. And in there you'll find several, a few flags of rejected observations that they did not go and reobserve, but there is sufficient redundancy and degrees of freedom that it was there is some points that are not as well defined as others.
Okay, but you're basically, guys are like basically claiming I can go out there with the equipment that they have and I can look at something 183 kilometers away and get an accurate azimuth reading?
An accurate angle to another point, yes, because they did, and you could too.
The document says that with the large triangles, they can't actually see it.
No, they specifically say in the West, where they were able to get these heroic-looking distances, that accelerated their traverse across the continent. In the plain areas where they had to build towers and shit, the triangles were inherently smaller and things went slower. But they did say, and the 182 mile observation was the longest in the entire survey, and that was optically observed. Yes.
Okay, well, I read where it says that they can't observe it to basically fill it in. But anyway, so what I want to know though is, like, you keep on saying that it's just a raw average and they don't throw any of the measurements out. They just take them, write them down, and average them out. Does it explain that in the document?
It may. I did not. There are paragraphs I have not yet read. There's a lot of math involved.
I can't say that it does. I can't
There
say
are
that
a
it
ton
does
of
or it
adjustments
doesn't. I can't say.
observed angle.
Excuse
That's
me.
before correction.
That's why they do state that they took 14 or 16.
Can anyone else hear Blue trying to talk?
Apparently not. No, to be honest, I cannot tell you.
Larry.
Go ahead, Larry.
They do state in the paper that they took an array of 16 or 18 repetitions of any angle. And in that 18, if one stood out, okay, they had 17. But if in that 18 it's particularly noisy, then yeah, it gets flagged for reobservation. And that did not occur very often.
Where does it say that, Larry?
I'll have to find it because now I'm a bit dizzy with page numbers running all through my head.
Okay.
Did you want to get something in, Blue, before they started again?
I was just waiting for somebody to tell me it's my turn.
Yeah, I know.
I'll allow you to speak.
I don't know for sure if it ever says that, Whitsitt. I don't know if it actually says that they took individual 16 measurements and averaged them. I can't tell you that. I also can't tell you what type of binding they had on the books, on their field books. I do not know what type pencil or writing instrument they used. I don't know that either. None of that's in there. There's a lot of things that are left unknown.
Yeah, that doesn't seem particularly comparable. So
this is not a training document.
No, not at all.
Yeah, that's cool. So anyway, what it says in the document is that they use the Clark method. Okay, and when I went and looked through Clark's document describing his method, it 100% has spherical assumptions. And in fact, he spends a large time in the paper explaining why those assumptions are justified.
But
he justifies the assumptions.
That's the adjustment process.
What it never
field observation of the angle.
What it never says is that Clark method was employed with the observed angles, does it?
Well, I haven't read the whole paper.
It doesn't relate to that. It doesn't relate to that at all.
I dropped the screenshot for you guys and asked them to explain it, and then no one ever did.
There is a spot in it that says that the Bessel method was used and with the observed angles before corrections. And I can get that for you and post it.
Please do.
And can we come to an agreement here that if there is any version of spherical assumption factored in prior to recording the observed angle, then this does in no way actually demonstrate the errors of ball?
How would you do that?
Can anyone answer my question? I mean, it seems like
the point is, how would you factor in spherical assumptions before you take an observation?
Well,
how would you do that?
For one, what you could do is you could apply a weighted equation to the actual average you're getting for the observed angles, because the observed recorded angle isn't just every one they see. It's just one of them after they take whatever 18, 20 of them. So if you take a weighted equation, well, you get your weighted equation from the reference spheroid. So you say the reference spheroid predicts 8, and then you get a 7 and a 6. Well, you're going to apply more weight to the 7 because it's closer to the predicted 8, right? So if you're using a weighted equation built upon the reference spheroid to actually run your observed angles through before you even record them, and then you make an additional correction with the spherical excess formula, which seems to be what happened, well, then there's actually a correction made in before the raw observed angles recorded, and then there's an additional spherical excess formula correction after that to get the adjusted angle.
So I'm trying to steelman your position, which is that before, when they take the measurements, they take several measurements, and then they don't write them down, or they write them down in a side piece of paper, and then they weight them towards the desired result, and then they write that number down. Is that correct?
Well, yeah, they run it through a weight equation. Yeah.
Right. Do they like do that in a side piece of paper and then write it down in the in the record? Is that what
They
you
would
think?
probably just write down all their raw data, and then they would go to the office and they would run it through the weighted equations, put the observed angle there. Then they would apply a spherical excess formula to the adjusted angle for the correction additional to that.
Okay, where does it say that? Where does it say that exactly?
Well, that's what I'm trying to get to the bottom of.
We have the raw data, though, Witsit. We have the raw data.
No, we don't have the raw data.
No, I'm going to play the same game you're playing with it. Where does it say what you just said?
Well, that's what I'm saying. I'm openly admitting I don't know, and I'm trying to get to the bottom of it, right? But it's all of a sudden it needs to say it, because just a second ago we can just make assumptions and we doesn't need to say it.
Are you going to make you're making an assumption?
I'm literally
you're
not.
doing the same thing that you're accusing us of doing.
No, my dude, I'm asking. Like I asked the question and then I had to go to Florida. Now I'm back and you guys are talking about it, so I jumped in here to ask the question. I've asked the question for days now. Can someone cite in the document where it says they just take a raw average and they don't throw any data out and they don't apply anything weighted? And no one ever answers. No one, they just say stuff like, oh, that's just how it works. Oh, Wither doesn't know how to do averages. All this gaslighting, all these ad homs, but no one can just answer the question. I mean, I got ballers in the chat talking about average and mean are the same thing. I'm like, weighted means are not the same as averages. So the irony of you guys, which it can't do basic math.
So you think that there must be there's sheets of paper that they threw away before writing down the official raw data, right? Is that what you think?
First of all, it's not about throwing it away. All the ballers admit that the actual measurements taken are in the field notes and they're not in this PDF. They just have the one observed angle. Yeah, that they all.
And what are you saying, Brenda? That they typed the paper as they were taking the angles? Of course, they were written down before. Kind of a nonsense question.
Yeah, I'm about to do something real fast. So, but like, I'm just trying to get to the bottom of it. Like, I don't have some bias. I mean, I know you guys think I do, but to me, I just want to see what actually happened. And it seems like there's a narrative been floating around where, because I've been talking to identified editors, they've been repeating MC Tune. And what he's been saying is they just write down the raw data. The raw data, they all say the word raw data over and over, right? Even though the raw data is not actually in there, okay? And then they say they apply the correction is just an average of the raw data. That's what the correction is. And that is patently wrong.
So I'm just trying really hard to steelman you. So you think that in the field notes, they would write down the actual observations and then apply a weighted formula to those field notes. And then that weighted formula, the results of, are put down in the official document. And that is my understanding, right? Right, Witsit? He stepped away, I think.
Yeah, he
I'm
thinks
still
they
trying to get
somehow
him, even though I haven't been here very long to understand his actual question or argument.
So is that what was done? So there do exist then field notes, which have the direct observations, which are then weighted, and then that weighted result is written down in the PDF that we have. Is that correct?
Yeah, obviously they'd have to collect their findings and then later on, then it's deciphered and calculated and then written out into a format that's in a book.
Because you have to understand that a flat earther is always going to go with a conspiracy interpretation. So he's going to say there's a conspiracy to alter the raw data, and it happens between the field notes and the publication. That's what he's going to say.
Right. Like they measured planar triangles, and then when he got back to the office, they were like, "Oh shit! Now we have to add spherical excess to them."
Yeah.
That's 100% what happened.
Okay. Right.
It is.
So
It says
you
it's
guys,
supposed
you guys think, let's say we go and measure one of those big triangles. We do it once. We don't do it 18 times. We do it once. You think we will not find spherical axis?
If we did it once, yeah, I don't think we're finding spherical excess.
Problem is, this isn't the only time they did
Even
this. They
the
did this
observed
all over the
angles that they
world.
recorded were literally
Where-
right at 180, give or take.
We're not
They
looking
did this.
for.
They did
We're
this
not
all
look-
over the world, not just
Hold
in
on.
this document.
Hold on. We will not look for accuracy or how much. How big is the sphere? Just if there is a spherical axis, you think we won't find it? You were told it's on the order of 20 arc seconds per angle. You're not going to get
Don't even
away
know what
with
you're
it.
saying.
However wrong you will be, even if in 10 arc seconds you will be wrong,
Don't even
you
know
will
what you're
still
saying.
get the spherical axis. No averages, no weighing, nothing.
Okay, so just prove it by showing the raw data that they collected, because
Go
even the
take it.
observed
Go
angles
take
that
it
they
yourself.
collected
Go prove us
are
wrong.
showing that they're
Go
right at
take the
180.
data yourself. Prove us wrong.
They're right at 180. They measured that.
Go take equipment. Go on those mountains. Take the measurements. Prove us wrong.
Dude, they had to reduce each
No,
triangle by
you prove us
1/3.
wrong.
Let him say it. What
Okay.
he's going to say.
I don't
He
have to. I'm
stop doing
proving
that.
the paper wrong.
You don't have measurements. How you prove the paper wrong?
Because I'm reading it, and I can read words, believe it or not.
Yeah, please let's see the words you read.
So computation of spherical excess of the triangles. For all parts of the triangulation which lies east of the Rocky Mountains and which traverses the plains and gentle slopes of Kansas, Missouri, and Ohio, the comparative shortness of the sides of the triangles admits of the application of Legendre's theorem in its simplest form. The spherical excess in seconds is given by blah, blah, blah. There's an R in the formula where A, B, C refer to the sides and the included angle of the plane triangle, whose angles are those of the corresponding small spherical triangle after each has been diminished by 1/3 of spherical excess. When greater precision is required as for larger triangles which stretch across the peaks and ridges of the Allegheny Ridge, we introduce the radius of an osculating sphere. And then take another big, giant, stupid equation. And for triangles of unusually large size and approaching the limit for possible observation, certain terms in the development of the theorem, which ordinarily could be neglected, needs examination. It has been shown that spheroidal triangles may be computed as spherical and hence as plane ones by application of the same theorem extended. All right, they're literally taking a formula and adding the sphericity to these triangles.
No.
That's
what
after.
stage? At what stage?
Yeah, exactly. At what stage? So
yeah, at what stage?
I don't think that matters. If they're measuring them all and then they're correcting later for a sphere, it's not proof of a sphere.
No,
No, if you're identifying,
your arguments.
no, if you're identifying that they're actually putting sphericity into the formula, you should be able to identify where they're putting it in.
Well, I'm just reading the PDF.
Yeah, I think
I'm
you're reading
assuming
and
it's after.
misinterpreting what they're saying.
Oh yeah, that's a good one by you
Yeah,
guys.
that happens all the time.
I know. It happens. I think every single time a flat earther reads a paper, it's out of context, right?
Yeah, I mean,
Yeah,
you think that they're just
yes.
adding
Your answer was yes,
just
right?
to make it look like the Earth is a sphere. They're just adding it just to make it look like it. That's
That is
come on now.
100% what they're doing.
Okay, and they did it all over the world, right? Even in India too.
Yes, this is how geodetic surveying is done. You
Really?
want to argue it? Go look it
How
up.
many years have you done geodetic surveying?
0.
Okay.
Yet I can read words.
The ellipsoidal shape of the Earth is well known, so they weren't out to discover if it is or is not. They
See,
were out to
see, guys, listen to him. Exactly. They knew it was a
Yeah, the
sphere,
South Pole exists.
so they added
Yeah.
the sphericity after the measurements.
Because we already knew about it, of course.
See, of course.
We
Now you
just
guys
wanted to
want
know
apologize to
exactly.
me?
We wanted to
Wanna
know
apologize to me,
exactly
guys?
how it
Let me
worked.
guess. No, right? Was I reading out of context?
They still measured spherical
Was
excess.
I not
though.
understanding?
The
They
problem
still
is
measured
you
it.
measured spherical
No,
excess.
they computed it.
They
I just
still
read it.
measured
They didn't
spherical
compute
excess.
it. They
Nope,
measured
they
it.
computed it. They
They
computed it.
measured spherical excess.
You have the
Spherical excess is what we're talking about. That's what we're talking about. They
Yes, and
applied
that's
it.
what they measured before any of that other shit you're talking
No.
about came along.
Yeah, well, no, there is the spherical excess that is observed, and the spherical excess as computed in the Clark 1866. And the comparison of those two is the whole point of the survey, because they're comparing the fact that it is in fact 1 or 2 half arc seconds larger than the Clark 1866, as was pointed out. It doesn't quite fit the Bessel and doesn't quite fit the Clark 1866 because the observed measurements versus the calculated anticipated spherical excess disagree by small amounts.
What you're saying though is by measuring spherical excess, that's after the adjustments for the Bessel method and the Clark method.
No,
it
is not.
No, that's in the simple. That is in the simple addition of the 3 angles of a triangle, and it's in the excess of 180 degrees by some 35 arc seconds in the case of Pagre. Yeah, it measured to be 35 seconds, and it calculated to be 34 and a half seconds.
That's right.
What are you talking about?
That was pretty clear, I think. They measured 35 arc seconds of spherical excess. When you compare that
35 arc seconds.
When you compare that to what the Clark would say it would be, Clark would have said 34 and a half. It's half an arc second off.
Or so.
Well, that's also a spheroid, not the spherical Earth.
The fact that it's a spheroid is known and accepted. This was not to discover.
Oh my God. I understand. Just don't say it's proof of the globe. That's all.
No.
That's all I'm
The
saying.
proof of the globe is the fact that it fits so well to the ellipsoid as published.
That's right.
Right.
There's a prediction. You have the Clark ellipsoid is a prediction. Okay, you go out and you measure it, and you know your measurements, your field measurements, are very, very close to that.
Except that those field measurements had adjustments added into them before they did that.
No, they didn't.
No, not before.
Yeah, they did. They
No,
had
they
station
didn't.
adjustments made. They had a bunch of adjustments made for pretty much everything.
In the adjustment process.
No,
not the observation process.
Nope. Added to the observed
It's right
angles.
there in the fucking
That is
paper.
the adjustment process.
How could you consistently add adjustments to the raw observations and get the correct answer? Because unless they're just like fantastic computers in their head. No, but
what
how
are you
could
talking about?
I mean, they would have to add it to the raw
Oh my God,
observations.
they would have to write down the actual observation that they took and then run it through a method, Clark or Bessel method, to then get the angles that they're writing down as the observed angles. Wow, that's so hard. I don't know how they would do it, Brenda.
Well, actually, the least squares is pretty involved. So
Okay.
that would be, yeah. So that
I don't
wouldn't be
understand
easy.
why you think that wouldn't be easy.
Because
It's
it wouldn't
really
be easy.
silly.
They didn't have calculators.
All right.
They had
all
to
right,
do
Brenda.
everything on paper.
Brenda, are
They
you
might have
kidding
had
me?
machines. They might have had adding machines.
They didn't
but-
have to do it right then and there. They could work all this after. I don't understand.
So they didn't do it in the field. They didn't do it in the field.
I don't know if they did or not, but they didn't have to. All we're saying is the columns that are shown here with observed angle and then correction are not the corrections that I'm talking about, that they already made to the observed angles. It says it in the paper.
Yeah, but you say it with no base. You have no proof that that's what's done.
I have no proof that it clearly says it in the PDF.
Where
Yeah,
does
it's just
it
a
clearly say?
supposition on your part.
All right, you guys are out of your minds.
Well, it's right. It's right there. Page 565. They have the triangle and the triangle across Pagre, Mount Was, and Tabitha. You sum the angles, which are from the abstract, and you get 45.5 seconds in excess of 180 degrees. On the Clark ellipsoid, you get 46.2. That's the discrepancy of which they're trying to refine the Clark ellipsoid. Yeah, that difference means that they had a predicted value, 46.2, and an observed value of 45.5. Yeah, that's the whole point of the survey.
Yeah, that's not inserting a value to arrive at a preconceived notion. That's checking your observations against a hypothesis. I guess you could say that,
Yeah,
couldn't you?
It's the Clark ellipsoid fit the measured field values for 0.7 arc seconds in spherical excess on a triangle that's 2,600 square miles.
Is that clear? Does that help out to you? I guess he's not talking. Okay.
Well, again, the fact that the Earth is an ellipsoid, as well as that's known, and this was not to discover if it's an ellipsoid or if it's a curve. This tests the ellipsoid that we know, or that they knew then in 1890, 1900, the Clark 1866 ellipsoid, and this virtually tests it because the fit is very, very high.
And the question, Larry, and how did Clark guess his ellipsoid?
I did not go into the deep dive of Clark's ellipsoid measurement.
But he did it from measurement. He didn't do it by guessing.
Oh, of course.
So they're just comparing one set of measurements to another.
As did the Academy of Sciences in 1770.
So in the one that you're talking about, right? The 567 or whatever, right? If you go up a couple pages to 583 or down, or no, sorry, 559. At the bottom, it says weights to the individual directions, meaning angles, entering into the triangulation were introduced as explained in part 1. I'm now going to part 1 and I will report back. But please deny me that I'm reading out of context again, please.
It is known that observations upon some signals which appear distinct and steady are more accurate than others upon signals which appear unsteady or indistinct. But the difficulty of properly estimating the relative weights and the extra labor of making the computations after they have been introduced make it advisable to assign equal weights to all observations. What do you think that means?
They had state-of-the-art equipment, and they were using state-of-the-art maps, and they were using state-of-the-art procedures. And it's 1890.
Yeah.
They had pull crank adding machines, pen and, quills and parchment. not a survey of discovery. They weren't discovering if it's an ellipsoid, and it's not a training manual on how to return a singular angle from 18 observations at a station point. And the plate is rotated, and observations are made at different times of days to involve as many variables as possible, and still have standard deviations in the neighborhood of a single arc second. Now, what is the threshold to flag for reobservation or discard? I'm not clear, but it's small. I mean, scale for the era of 1900. This is like taking 2 petaflops of data all at once. And they published it for everyone, academics around the world.
Where's this publication that you're just reading it from?
It's, yeah, I can get a link to it.
Yeah, I was just asking in the side chat. Oh, thanks, Anamorphic. Now, is this the PDF that Witset's quoting from?
Yeah.
Or questioning? Right. Okay. Sorry, I'm a bit late to catch up on all this, but
Because at a station point, I could go out there and I have no information at all of what the project is, just an instruction there. There's 6 distant points that have their illuminators turned on, and I have to measure the angle, measure it 16 times, 18 times, and make sure that that everything looks within specification. And specifications, yeah, you do the arithmetic right there with my shirt pocket calculator, see the standard deviations of the subtractions fall within the anticipation of the instrument. If I go out there with a wild T3, yeah, the anticipation is going to be like 0.6 or 0.5 arc seconds. As a standard deviation of the 18. And then that mean value gets entered into the adjustment process. Now, the adjustment process is to take the entire body of data in aggregate simultaneously. And those angles may, in fact, not fit all, down to the half arc second. Because there's all kinds of little local variations, deflection of prime vertical, and things which later in the 20th century were quantified and involved. And then we moved on to using satellites.
I like the lateral refraction that they had to adjust for. That was cool.
Yeah, very small quantities, but they couldn't allow anything systematic to get through. Lateral reflection is only something that occurs in, observable in the very large triangles.
Yeah, well, it's odd to have a density gradient that direction, unless you're going a long, long way.
Well, at the 100-mile observations, you can have one mountain range that's bathed in sun, and the other mountain range which is still covered in cloud, and you could have 20-knot winds running up the valley, Okay, you're going to get some scintillation and maybe some little bit of pulling. Okay, so you do it multiple times. That'd be part of the variations which are to be averaged out. Not talking averaging out arc minutes. You're not talking about, give or take a degree.
It's a feeling everybody's reading this damn PDF.
Well, that's a good thing. That's how you learn.
Yeah, that's why I wanted to have a look at it.
A lot of the maths in there have a lot of archaic nomenclature and symbology. So it's a very tough read. And the fact that it's back in the 1900s, all using logarithms and the normalized equations to be summed in antilogs. It's tough. It took them years just to go through the computations because all they had was a pull crank adding machines and a room full of housewives to go through worksheets and just do sums.
Anybody want to borrow my slide rules?
They didn't use slide rule. They didn't use slide rule. They used some very. They didn't use slide rule. They used some very exacting log and anti-log tables.
Is it metric or imperial slide rule?
Yeah.
Slide rules are unitless. They had the same hurdles with the trigonometric survey of India when they surveyed across the Himalayas. They ended up with so much data that they ended up with years of computation.
Yeah, corrections for temperature, correction for pull, corrections for sag, correction for horizontal alignment, vertical alignment. Geez, they had a lot to throw in there.
Well, there's the aspect of metrology, which goes into the base distance measurements and the characteristic of the instruments and how to use the instruments. Yeah, and statistics. And truth be told, a lot of surveyors are poor at statistics. If you look at the angles that are in the abstract, you go out there today, you're going to measure that same fucking angle, give or take very small tolerances, not 20, 15 arc seconds different because of spherical excess.
Okay, sorry, I do some. You guys sounds exciting in here.
Yeah,
we're doing some homework.
Did we ever figure out the question? Like, does it specify what, like, the process that the raw data goes through before recording the observed angle?
Yeah, well, they claim that there wasn't one, and then I shut them up real quick by reading part 3.
Well, I think I shut you up, didn't I?
Describes how they adjusted for the observed angles before entering them into the triangulation.
That's not
So
what
now
that
everybody's
said.
trying to read up on it.
That is not what that said.
Well, okay, can you drop a screenshot or something? Because it's not very convincing.
So which
All I
section
know,
in
one thing's
chapter
for
3?
sure, is there's been lots of misinformation floating around about the survey for a few years now. regardless of what's out to be the case, that is certainly what has happened. You got people like Brenda screaming at me, that's just the raw data, and the correction's just the averages. You got, and that's not what it is. So at the least, this needs to be like productive in that sense, right? Like, there's been misinformation floating around about the survey for like 4 or 5 years. And it's like, what's up with it? Like, do the math. So whenever I sit down with Mattoon and I'm trying to get him to agree to a live debate, and I pull my iPad out and share the screen and I run through trigonometry faster than you guys can, are you guys just going to finally let go of the fact that just screaming you can't do math doesn't make the earth a ball,
So it says, hold on. So what I read was, it says,
where are you quoting from?
Yeah,
I'm
we
just reading what I read
lead.
before.
Where?
Weights to the individual directions, meaning angles, entering into the triangulation were introduced
Which
as
chapter
explained in
and
part
which
1
paragraph?
and exemplified in the adjustment of the YOLO basenet.
Where is that? What page?
What I just read there is page 559. But then you go back to part 1 and it starts talking about it, I think page 36. I haven't gotten through it yet. I'm still reading.
Hey, what is it? What exactly are you doing when you wait? I don't want to skip past that. Like, what did it say?
It said that weights. Hold on, let me read it one more time. It said, weights to the individual angles entering into the triangulation were introduced, as explained in part 1 and exemplified in the adjustment of the YOLO basenet. So I'm going back to part 1. I'm on page 36. Hold on. The beginning of part 1 starts talking about like a conversion method and a coefficient for it. That's not what we're looking for. Page. Come on, where was it?
I'll be back home in like 15 minutes and I can try to look through it as well. But...
Yeah, at the bottom of page 36, it's titled The Local or Station Adjustment of Horizontal Angle and Direction Observations. So that's what I'm reading right now.
So they introduced weight into the angles that are put into the triangulation?
Yes, before they were entered in. So the observed angle column that they think are just raw measures or an average of the raw measures are actually corrected or adjusted or whatever beforehand.
If they're weighted, then the whole debate's over. That's what I keep trying to say to everyone. I want to figure, if they're weighted, can everyone agree that if they're weighted, then that means you baked the sphere into the measurements?
No.
See, that's what. Where do you think you get the weight from?
Well, you weren't here when I read the other part where it says everything was given an equal weight.
Everything was given an equal weight.
Yes.
I do remember reading that part.
That was only for
a
couple of them.
But the difficulty of properly estimating the relative weights and the extra labor of making the computation after they have been introduced make it advisable to assign equal weights to all observations.
Yeah, keep reading.
The actual computation of the coefficients in absolute terms, that's talking about an equation, I think, is therefore much less laborious than would appear from the form shown in another equation, number 6. This computation is also considered shortened by grouping together all series in which every one of the D signals were observed. All series in which D, what is it saying? D minus 1, D approximate something. Signals were observed and so on. Anyway.
Okay, because I'm pretty sure right after that it explains that approximations have to be made because it's basically such a dense formula.
It says what I just wrote or read to you.
Yeah, but right under it, it explains that the equation is such a heavy equation that approximations and assumptions have to be made.
It basically says it doesn't make enough difference that it warrants all the extra work.
And it also is pointing out that additional computation is warranted. This is to get the publishing of the raw data and an adjustment, a preliminary adjustment for further study. And this was, and at the end where it says preliminary output, yeah, the final output was not published for years because of that computation.
Yeah, but why does it?
Because the assumptions were carried out. They were not assumptions later on. But at this publishing, they point out expediency to get it published for the academics to investigate.
Yeah, but if they're just talking about smaller triangles, then this doesn't help you guys. So, like, what's going on when what he read that it says that they actually apply corrections and weight prior to the input into the triangulation, applied to the observed angles?
It does not say that.
What does it say?
Read it again.
I'm driving, man.
Have him read it again. It didn't say they applied that before the observations.
Yes, it did.
It says before it's put into triangulation.
Weights to the individual directions, angles, entering into the triangulation were introduced. Thank you.
Because, I mean, we're going to get to the bottom of it, right? I mean, like, I can give you my perspective. My perspective is that whenever you hear an alleged globe proof, all the anti-flat earthers are so sure about it, and they all repeat a script at you. It's usually flooded with ad homs and gaslighting and stuff. And then when you get all the way to the bottom of it, you find out that what they said isn't true. And then one of two things happens. Either it's just ignored, or usually the latter. They just double down and repeat the script over and over. And so that's just my perspective. Like, I'm not making any claims about what's going to happen. I don't really know, but like, that's my experience consistently. I know one thing, that like people like Brenda pretending that they're teaching me about this because they're repeating the misunderstanding of Mattoon, is not globe proof. I think we can all agree that if they go in and they reference a Clark ellipsoid model, and then the Clark method says, well, when you take your observed angles, interpret the angles this way, use this weighted equation based on the spheroid the reference spheroid, and then get your weighted mean that way, right? If say they're going out there and they're just throwing out a bunch of measurements that don't comport to what they want, they're adding a ton of weight to the measurements that are closer to what they want, and they get an observed angle that's relatively close, and then they apply additional corrections to make it more exact to see the difference, and then try to refine the ellipsoid. This is actually the opposite. If that's what they did, hypothetically, that would be the opposite of globe proof. Because I know it says they use astronomical spherical coordinate systems. So you get like the meridian using an astronomical spherical coordinate system. You get your longitude and latitude that way. They make spherical latitude corrections. And every single time I bring this stuff up, people just say, oh, that's just for the adjustment portion. That's just for the, like, they just say that. Just like they just say it's a raw average. But it's like, no, what does it actually say? Can you guys cite everything that we're bringing up with our questions? We're citing it. Page 56, page 40, page 41. But like, you guys are just saying it and then saying, oh, well, they didn't put that in there because everyone knows it.
Like I pointed out earlier, there's a lot of things they didn't put in there.
But the base method would definitely, this is a very meticulous document, dude. It's 900 pages. It's like overkill with detail. So I don't need to know what binding their notebook is. I want to know the base method, right? Like how you're actually taking your observed data and what you're doing with it would be one of the most important details. I mean, that's the crux of your guys' entire argument. Another thing that keeps happening is this is, of course, the globe earthers' claim. They're like, this is proof, or nothing can be proven, so it's evidence for the sphere. We went out, we measured the Earth as spherical excess, right? The sum of internal angles on a flat plane can't equal more than 180. These equal more than 180. They show spherical excess. This is evidence that the Earth is a ball. Can't happen on a flat Earth. It's a positive claim by the globe Earth. And then we start to critique it. They're like, why don't you do the math? Why don't you figure it out? Well, why don't you do this? Like, it's like, this is your claim. It's the globe earthers' claim. You know, trust me, I would be down to actually set this up, but it's really easy to be like, why don't you guys go make the measurements? Dude, this took them years and tons of money, tons of people devoted to it. So it's really a safe area to be like, why don't you guys go replicate it? You know what I'm saying?
Oh, we got much easier ones you can replicate.
Well, everything I see says you're not supposed to be making angle measurements hundreds of miles away.
Really?
Yeah. Like the range of accuracy is not hundreds of miles. And you guys claim that claimed there's no lateral refraction, but this document says they do have to account for lateral refraction.
So an arc second knows what a mile is?
Do I?
Why does distance make any difference? An arc second is an arc second.
Yeah, accuracy is going to decrease with distance. You're looking through more and more atmosphere. You guys.
An arc second is an arc second.
That's what Rakia. That's what Rakia says. Rakia is full of crap.
Dude, their document says they have to account for lateral refraction.
Yeah, they got to account for a bunch of stuff, and it definitely says that as it gets longer, the sides get longer. They have to use approximations. So it's got to be harder to measure angles over long distances, or they would have done it.
And it's funny that that's the only ones they want to bring up out of the entire chart. Also, something else I'm confused about. So it's like, say that you add up the angles and it's 179, right? Say 179.58, hypothetically, right? And then you guys are claiming that the error margin is 1 second, and you're claiming that the observed angle is actually the average. So if we took a raw average and we get an arc second below 180, then that means that there were measurements far below that. And if it's hypothetically, if it was an arc second off, then that means that there were measurements far beyond the margin of error that were less than 180.
You can't just say that.
Because the average, do what?
You can't just say that.
Well, I'm saying you don't agree that, like, say that I'm taking the average. If the margin of error is 1 second,
yeah,
I take an average of 18 measurements, and then the average gives me 179.59, but the margin of error is 1 arc second. That means in order to get 179.59, there would have to be measurements below that for that to be the average.
Not quite the way averages work, Witsit.
It is literally how averages work.
No. I can get 179, 59, 59, and I can get that 18 times in a row, and the average is 179, 59, 59.
That's not my.
Give me a break.
Okay. Yeah, fair enough. So you're just claiming that they got the exact measurement over and over? I mean, logically speaking,
no, I'm not claiming that at all.
Middle.
I'm not claiming that at all. Not at all.
Well, it's just, but unfortunately for you guys, we can't actually verify that part because it's not even documented.
You made a statement that some of them had to be way off. And, well, I don't agree. There's no data that tells me that.
Yeah, fair enough. But it doesn't have to be way off. It would be more than an arc second. if like the average is 1 arc second below 180, and then the spherical model's prediction is a little bit over 180, and the average is below 180, that means logically speaking, there are measurements even further below 180 than the average,
and
that would be outside the margin of error.
And measurements further above 180.
Yeah, but you guys are claiming that it's that the ones that are not over 180 are just margin of error. And if they're taking a weighted mean, it gets even worse, right? Because say you take a weighted mean, it's
They're
like
also the only time that occurs is in the small triangles. Yeah.
You mean where the measurements are more accurate?
No, small triangles. Small triangles. The spherical excess is not easily observed.
Yeah, but are the measurements more accurate? Yeah, of course.
No,
and this is
an arc second's an arc second.
In a
small triangle, in a 2-second error in a small triangle is it is no different, than a half a second error in a large triangle.
That's totally irrelevant to my question, which is, are like shorter measurements more accurate? Everyone knows the answer is yes. Duh, surveying 101, I thought you were a surveyor, but this is a part that I find very interesting. This is what I'm trying to get to the bottom of. If it's actually a weighted mean, if the observed angles are weighted mean, and some of them are below 180 or outside the margin of error, that's really bad for the globe, because that means that even applying the weight distribution in favor of the reference spheroid, you still were below 180. Then that means it's nowhere close to the globe prediction.
I read it to you, Witsit. It says specifically that every measurement was assigned an equal weight when it came to the evaluation of spherical excess.
Well, I'm going to be back to the house and we'll get to the bottom of what it's saying, because right under that it says that you have to use a very dense equation with assumptions.
I'll find it again.
Well, yeah, read like 5 sentences down, and it says that the equation is so heavy that you have to make assumptions in the formula. But I do remember reading it saying that they apply like equal weight to everything. But I'm trying to understand exactly what it means. You were talk about cherry picking, right? Just like see the sentence that says equal weights and be like, oh, there you go. Come on, man. Like it's in the context of it saying that there's such a heavy formula that it requires assumptions.
Yeah. To
And
derive.
it warranted further computation. Yeah. They were not finished. That's why the results at the end were published as preliminary.
Yeah, but you're baselessly asserting that there were no computations prior to the correction column. You're just saying that. You just keep saying it, but it doesn't make it real. Every time I bring up the corrections, you're like, oh, no, that was just for this. Oh, that was just after this. You're just saying that. No matter what I say, you say, oh, well, that was part of it. That's why I asked you specifically, wait, you agree spherical excess formula is different than weighted equations. So are you claiming they applied both of them to the observed angle average? And then I got Rumpus screaming, and I got no answer.
Derive the probable error of an adjusted angle by the rigorous method. It involves so much heavy computation in solving the various weight equations that one is forced to use some approximate formula for computing it. That's
Correct,
what you're talking about, right? What's it?
Yes.
Yeah, and the approximate formula is right above that.
Okay.
Okay.
So they had to approximate adjustments for the angles before.
No, they didn't have to. Read what it says.
They didn't have to. Okay.
Well, I'm going to get to the bottom of it.
It says, by the rigorous method involves so much heavy computation in solving the various weight equations that one is forced to use some approximate formula for computing it. In other words, it is just too goddamn complicated to do that on every measurement in a rigorous manner. Yeah. You need a better way of doing it. That's what that says.
Instead of them going through all the probable error and all the crazy adjustments they had to do, they used an approximate formula to compute it. They were forced to. Meaning they adjusted the angles before the triangulation.
Oh my God.
Right. That would if that's the case though, you have to admit that would be against your stance. Like if for one, if it's like you just take the measurements and write them down and average them out, then none of that would matter. Why would that even matter? And like, I'm just keep asking the Globers the same question over and over. You guys agree that spherical?
Go ahead.
You agree that spherical excess formula and weight equations are two different things, okay? So are you guys claiming that they applied both of them to get the correction column?
Which correction column are you talking about?
Well, look, you'll see the observed angles, and beside it, you see the corrected angle, right? So when I brought up that they specifically lay out weighted equations, he said, oh, that's just for the correction. So that would be the correction column. But then when you read through the document, it says they apply a spherical excess formula for the correction. So are you guys claiming that they applied both of them? Because to me, and again, I don't know, it just seems to make more sense that they're applying them at different times because they're different things. So you would apply the weighted equation to get your averaged observed angle, and then you would apply the spherical excess formula to correct that to the corrected column. You guys are claiming that they applied both of them after the observed angle to the corrected column. Well, you have to claim that, right, based on what you've said.
Question was, do you think all of this questioning and wondering is going to make the spherical excess go away?
If they have to bake in a reference spheroid, then yeah, it would literally do that. Yeah, take the
Austin,
out.
they didn't
Why
bake in a
won't
reference
you
spheroid.
won't you write that out and show it to us?
Yeah, okay, but this is why I keep saying it's like you guys
Austin,
always shift the burden of proof.
They
You
didn't
keep
bake it
saying
in,
that.
Austin.
Yeah, you keep saying that.
I don't know. You are the one that keeps saying that they baked it in. So you have the burden of proof to support your claim. You're the one that specifically said during this video and last week, specifically you claimed that they baked it in. So you have the burden of proof to show where they baked it in and how they did it.
Okay, well, actually what happened was you made the claim that they just took a raw average and that's what the correction column was. That's what you said. And now we've discovered, no, apparently the average is how you get the observed angle. And the spherical
Austin,
excess
you're deflecting from your very specific claim for which you have a very specific burden of evidence that you will need to support. You specifically claimed in this video and last week that they baked in the radius of the Earth.
You guys notice
have
that
the
all
burden of
ballers...
evidence. You have the burden of evidence to support that claim. Now you will deflect from your burden of evidence because you know you can never do it. Go ahead, deflect.
No, I actually fully intend on getting to the bottom of it, and I have specifically stated that I don't know everything about it. But
then why are you even in here talking about it? You clearly don't know anything about this, and I get that. So go ahead, go back, get out your pencil, get out your paper, get to work, show the math, find where they baked it in, find the step of the process where they baked in the math.
The arrogance, bro? You've been shown to be wrong so far, so why the arrogance?
I have certainly not been shown to be wrong so far.
Yes.
You don't.
Yeah. Wait. Let me lay it out. Watch. You're gonna interrupt me. I guarantee you, McTune interrupts this. So whenever we were first talking, I said, "So what did they do for the correction column? What was the correction that they applied?" And you said they just averaged out the observed angles, and then you pulled up a graph that showed intersection points. You said that's what the correction was. It was just an average. Now we know for a fact that's not true. Okay. Now
I'm sorry, Austin. For a fact, they were definitely averaging out the intersecting points so that they could have corrected intersecting points. There's like Larry was saying earlier, you get a constellation of intersections. You need to get your least means, your least squared average of those points.
What Larry was saying was that you were wrong. That's what he was saying.
Oh, well, is Larry here? He can maybe clarify
Yeah,
that.
sure. You claimed the correction column.
Sorry, you're not
the
Larry.
Average.
Is Larry here?
Can you just admit the correction column is not the average?
I'm sorry. Is Larry here?
Can you answer that question? Is the correction column
Could
just
somebody
applying
other
an
than
average?
Austin, since he won't answer the question, somebody other than Austin specify if Larry's here, because I don't know.
You're the one that's scared of the question.
But Blue Marble, is Larry here?
I don't know.
He's muted at the moment.
Okay.
Hey, can you admit that the correction column is not just factoring in the average? Crickets. Can you admit the correction column is actually applying a spherical excess formula?
So Austin, here's what you're missing. You look at the specific corrections. You look at the different ones that they have, like especially on the East Coast there. It is a zero-sum game. All of the adjustments that they make add up to zero. And since they have these azimuth plates, right? They're measuring angles around a circle. They have to sum to 360 degrees. If they are baking in the radius, they're going to have to add something to all of these triangles somehow. Yet all of them still sum to 360 degrees. And when they make these adjustments that they were making, they were making these adjustments, and they would add 0.01 arc second to this. They would subtract 0.02 arc second to somewhere else. They would add 0.01 arc second to yet another one.
They add 1.73 to this one.
I wasn't done, Austin. All this projection about you complaining and whining and bitching that somebody's interrupting you, and then you interrupt me. Hey, bitch, shut up and stop interrupting me. Stop interrupting me, bitch. Hey, bitch, stop interrupting me. Hey, bitch, stop interrupting me. Got it?
He's so triggered.
Hey, bitch.
Oh my God.
Hey, bitches, you can't stop interrupting me? You just got to sit there and whine and complain. Oh, they interrupted me, and you're the one interrupting me.
I'll just sit here and be a bitch.
Shut up. So shut up.
No problem.
Got it. So it's a zero-sum gain. All of these adjustments that they're doing, they don't get an opportunity to add the radius of the Earth into them because they add something somewhere else and they subtract something somewhere else. It adds up to zero net adjustments.
Can you admit that the correction column is not just applying the average?
No.
Okay, so this is where you and Larry need to go talk or something because you're just objectively wrong. But to be honest, a 5-year-old could figure out that you're wrong because there's only one observed angle provided. So you, of course, can't take one angle and then average it out to make the corrected angle. The observed angle allegedly is an average. Now, where it gets interesting is actually it looks like it's a weighted equation that's applied to the observed angles, right? And that's where you would bake in the R value because the way that you distribute the weight is based upon the ellipsoid prediction. So the reference spheroid gives you a prediction, then you distribute the weight based on that.
Again, you missed the part where it's a zero-sum game. There is no opportunity to fake in the radius of the Earth to any of these because in order to do that, you would have to add some to every one of the measurements because you assert that the Earth is flat. All of the measurements would, in reality, sum to 180 degrees. In all of them would have to, all of them underlying would have to, and then all of the adjustments would have to be added, specifically taking into account blindly, not documented in here, and doing all the trigonometry to automatically include the radius of the Earth in all these. But the problem still stands that it's a zero-sum game. All of the adjustments that they made to the azimuth plate readings sum to zero change.
Okay, so let's talk through this. So you have the observed angle, you have an observed angle column, and then you have a correction angle column, right? So when we take the observed angle and then we apply the corrections, what is applied to get the correction?
They are using, they are not, so you're misunderstanding when you're like, there's only one number. Now, what they're looking at is the intersections of a multiplicity of triangles. This is the base net that they're talking about. There's a large number of triangles in there. And so every single point is being measured with angles from multiple other points, not just two other points. So there's many triangles, and each vertex is a vertex of many triangles. So when you have 3, 4, 5 different triangles that one vertex is participating in, all of those different points do not meet at the exact same point in three-dimensional space. So they take a weighted mean, yes, a weighted mean to do that. So they see, well, which adjustment would we make here to make it a correction? So this one here, this one needs 0.2 arc seconds reduced from this particular measurement. Over this one over here, we need 0.1 reduced from it. Well, this one over here, we need to add 0.3 arc seconds. The problem is, Austin, that all of these triangles, right, they're making these adjustments that are maybe in the 0.1, 0.2, and then they get an arc second spherical excess of 1 or 2 or 3. So they're significantly larger than the adjustments, the sum of the adjustments that they made, even if you ignore the signs. So the opportunity for adding in the spherical excess that matches the globe isn't there. And it's clear if you start to add the numbers, if you got the pencil and paper out like I suggested and looked at them, you'll see that there isn't an opportunity to add enough adjustments.
Okay, yeah, but you're just taking the observed angle and you're mischaracterizing it as raw data. When of course we've discovered that the raw data would be in the field notes and that's not observed. So what you have.
Yeah, you've said that 1,000 times, Austin. Fine. I'll use the word correct or observed angles instead of raw data.
I bet if you interrupt me, then the Earth will be a ball. So where you're wrong is that the observed angle is an average. Technically, it's the product of a weighted mean, it looks like. Okay, that's reality. And then you have the correction applied to that. Yeah. You have a correction. The correction is not the average.
The correction is a different average of a different process. There's multiple times that things are average, not just one time.
Hey, would you like to admit that the observed?
Hey, would you like to admit that the Earth is a globe?
Would you like to admit the corrected
Hey, would you like to
column?
admit that the Earth is a globe? Got it. So the observed angle is whatever process they typically use in order to average them out, whether it's weighted or not. Doesn't matter. It's a statistical operation. If you disagree with the statistics, well, that's a problem for you, not for anybody else, because the statistics increases precision. It doesn't decrease it.
Can you admit that the correction column is not simply taking an average?
Oh, geez, Austin, again.
Just say
yes.
No.
You just repeat. Just put Austin on repeat. Rah, rah. You admit. Rah,
you are making yourself look
admit.
really
Rah,
bad.
You admit. Rah, you admit.
You're making yourself look really bad right now.
Yeah, sure.
Yeah, because it says in the PDF that they have a spherical excess formula, and they use something called the Clark method. They have a reference spheroid, and they use the Clark method. McToon, do you know what the Clark method is?
It's a Bessel method you're thinking of.
It says Clark method, but either one. Do you know what they are?
It's things that they're doing in the corrections after the observed angles.
Oh, so then the correction isn't just an average. Thanks for playing.
What do you think that Bessel method is there, Austin? Did you look at it?
Well, I looked at the fact there's a spherical excess formula in the PDF. They say that, and actually, when I went and read the Clark method, it says that you factor in all kinds of spherical assumptions.
Awesome. So are you saying that in that 0.01, 0.02 additions and subtractions they do that have a zero-sum gain, and yet the spherical excess is an order of magnitude larger? Are you suggesting that is where they baked in the radius of the Earth, as you claimed multiple times?
Well, they actually use a radius for both. Is my current
yes or no? Yes or no, Austin? Is that where they baked in the radius?
They did it in both scenarios because to get the weighted equation, the weighted equation, the way that you distribute your weight is based on the spheroid model. Spheroid models have R values, McToon. I'm not sure if you're aware.
The radius. Yeah, the Earth is a globe, and we use these things all the time because the Earth is a globe. Very good.
So now let me see if you can get this here. If I take observed angles and I write 18 of them down, and then I run them through in a weighted equation, and my weight distribution is based on a reference spheroid that has an R value.
I'm sorry. That's the lie there that you're talking about. You are claiming that when they're adding these, and this is very specific, and I get it. I get that you must assert that this is the case, but it's not, and you will find when you do the math that it's not. Well, you probably won't do the math. Anyway,
we can't do the math because it's in the field notes, but go ahead.
Yeah, but we know that you can't do math, Austin.
Good.
We know that.
Yeah, there you go. I bet if you just ad hom me, then somehow the Earth will be a ball.
That's not an ad hom, Austin. That is an observation. Being a math teacher, I know that if I can evaluate your understanding of math, and no, you don't. That's not an ad hom.
That's crazy. We should go talk to my college preparatory teacher who used to accuse me of cheating in algebra and tell him that some weirdo obsessed with flat Earth on the internet.
I'd be glad to just give you some might give you a math test right now if you want.
I'd be glad for you to answer my
No?
question. And
Got it. All right.
Yeah, that's
Got
right.
it.
I'm not. I'm on
So
my phone,
you
not
are
doing
asserting
anything
now.
for
Now
you.
you have. It sounds like you have now switched your assertion to that they somehow baked in the radius into the observed angles. In
See,
your
I'm actually not
ignorance of
making
how they
assertions.
got those observed angles.
Actually, I'm
Got
not
it.
making any assertions. I'm actually asking questions.
No,
and my
you
question
have
was,
definitely made the very specific assertion that they baked in the radius to these
You're
measurements.
unbearable, dude.
I mean, it's on this video, and you said it also on Tuesday last week.
Hey, buddy, you
You're
just
unbearable.
got thoroughly embarrassed. You just claimed
You're
that
unbearable.
you claimed in that video the other day that the correction was just taking an average. And then you doubled down today. You've had days to realize that you shouldn't be saying that, and you're still saying it.
But they are. We're talking about the East Coast triangles. Yeah, they're taking an average of the location so that they can make the adjustment.
So maybe I wish Larry was here just to correct you to save some time. Maybe he's just kind of embarrassed for you. But also, Mattoon, we just now found in the document that it says that there are scenarios that they actually apply corrections prior to.
Oh, well, what page would that be on? Let's see.
I don't know. I remember 356, 552,
Which
719. I don't remember. I'm
got
on
it.
a phone on
Got
my
it.
Jeep.
Got it.
Okay. Also, yeah. Well, okay. I'll be happy to give it to you.
Let's look this now here. I'll bring this up because what Regis, I think, was talking about the reduction of horizontal directions to sea level. Is that one of the ones you're thinking of there?
I don't know.
Well,
like I said,
I'll read it to you. Here we go. Here's the brings into Clark. So this correction. So the formula is 0.000066 times sine of 2 times the alpha, the angle that they're looking at, times the height of the observation point. And they applied that. They say this correction has been applied systematically to all measured directions of the base nets and intervening triangulation from the Salina base to the Pacific coast. But no application was made to the triangulation east of Salina base on account of the lower altitudes and consequent smallness of the correction in this part of the arc. And now you can see those actual numbers as a separate column in the correction listings on the triangles that are west of Salina base. And this goes on to say about the Salina base stations, the average reduction of a site to the sea level is but 0.02 arc seconds. Now, if you average out 0.02 arc seconds into these three angles of a triangle, you get a total of 0.03 arc seconds that they added. They certainly did add, adjust. And so, but when you have these triangles that are, multiple arc seconds, you're way more than 2 or 3 orders of magnitude larger. But it's also listed as one of the corrections, not one of the observed.
Yeah. So can you explain? Because I actually don't know this. What is the what does it mean when it says they make an adjustment for the direction?
So when they take the triangle, so there's a single triangle, right? So first they make the observations on the plate of the theodolite, right? And the theodolites that they're using for azimuth measurements are just azimuth theodolites. Typically, the vertical theodolite's a different instrument. They take this plate, they read the plates, and they do their averaging, and they report that. Then when they talk about the directions of the base nets and intervening triangulation from the Salina base, right? Those are the adjustments that they're making to the actual triangles, each individual triangle. So it's not an adjustment that they're making to the direction. If you look at let's see here, is this a page 60? No, we need to go farther down than that. But if you look at the ones, the abstract, where they list out each individual angle measurement, and they have a column that's this addition that they're putting in there for each of the triangles. That's what they're talking about.
Okay. So, I actually was reading through it the other day before I went out of town, and it says they make quite a few adjustments for direction. So like something about the base and direction adjustment.
Like I said, those are listed after the observed angles. There are modifications made after the observed angles.
Yeah, and so also from my understanding, in order to determine their actual.
No, they're not. They're field computations. It shows the weighted formulas that they use.
Page.
Hold on.
But dude, Mattoon, just trust me, you would be much better off to admit you just kind of misspoke when it comes to the
All right, you keep going back to
column.
this, Austin. You just love that.
Just say you were wrong, man.
Puff your chest up there, flip out your
It's
tail,
okay. It's
your
okay.
tail feathers, trot around the schoolyard.
Well, I'm not claiming to be an expert on this, I'm just saying if you would just admit you were wrong.
I don't know why you're even here then.
It would just give you a lot more credibility. You seem like you're being pretty stubborn. Just say you misspoke. Okay, it's okay. So the average would be actually how you get the observed angle column, not the correction column.
That, like I said, Austin, before, there are multiple opportunities in this survey where they did averaging, not just one time. You read one thing and you think it applies to only the one thing that you're imagining it to apply to. It's not. There's multiple times where they do averaging.
Okay.
I'm glad you accept that. Awesome.
Yeah, can you cite somewhere in the PDF where it says they just take a raw average?
Of what?
Of the
what
observed
specific
angle.
average?
Well, you guys are claiming that the field notes would have like 17 or 18 measurements and they just averaged them out with no bias.
They didn't detail the field notes to observed angles in there.
So we're just going to take your word for it that they just took a raw average. They didn't have because in modern surveying, you have like a window of acceptance, if something falls outside of it, you disregard it, you de-weight it.
As you should, yeah, you absolutely should, yeah. That is an indication of an error of some sort. It could be a blunder on the actions of the surveyor. It could be an instrument error. It could be
an assumptive error
at atmospheric conditions that were bad at the particular place. Any number of reasons can cause spurious data, and statistically you get rid of that, because when you do that, when you apply the statistics, it increases the quality and precision of your measurement. It doesn't decrease it, and it's not a way to hide the real truth of the earth. No, this is how you get better at things, not how you hide stuff.
Yeah, well, you guys, for one, said there was no refraction whatsoever with azimuth. And then we found out actually it specifically says there is lateral azimuth azimuth refraction accounted for. But of course, what I'm trying to figure out is, does it detail what that window of acceptance is? Like, where does it detail that in the paper? Or are you guys just
I think Larry mentioned 3 standard deviations as an example of something that he might do, and you did not seem to didn't seem to understand what a standard deviation was at the time.
I don't care what he might do. I'm talking about the PDF that you boldly make stuff up about.
And what I've said is that this, to my knowledge, doesn't declare how it got the raw data, the field notes, into the observed angles.
So we don't even know what the window of acceptance is.
You're correct. You're correct. It could be 3 standard deviations. Maybe it's 2. Don't know. It doesn't say. But what we do know is that this particular one, they do things like they say the number of days that they spent at a particular point. Right? They're like 15 days we were at this point. So they weren't messing around just taking 1 or 2 measurements here.
This seems like evidence against you, right? Because like, say that you got tons of measurements that didn't fit within your predetermined window. You just keep on ignoring them, and you only record the ones inside your window. And you have to admit that if they actually applied a weighted equation to the observed angles themselves, then that would be baking in the R value, right? You agree?
Absolutely not. You don't know what a weighted average means, Austin. That's very clear to everybody in the audience that the concept of a weighted average is meaningless to you. You think a weighted average is they put a number in and everything that's not next to that number gets weighted out. No, that's not what a weighted average is.
How do they determine how to distribute the weight?
Oh my gosh. Like I said,
you don't answer
Austin, they did not detail. You keep asking, you demanding that we detail for you how they did that. They didn't state it. Now there are some references to external documents that are like foundational things on how you do surveying. So perhaps they're in those. I have not read into those, but
Well,
you
you
go
should
right
go
ahead.
read
You
them.
find them. They're in the footnote. I don't
Well-
have between now and my next sentence the opportunity, or between now and the next time that you demand that I tell you how, the opportunity to read that, Austin.
Okay, well,
Is it significant that they said they applied it equally across the board?
Yeah,
but you
equal
guys
weights.
say
Yeah,
that,
they
but it
did
doesn't say that.
specifically said equal weights. Yep.
Yeah, but
I
it
don't like
actually
that.
says they used the Clark method and they used a reference spheroid. So if they're, first of all, why would you be applying any weight if it's just a raw average, right? You wouldn't even worry about weights.
Because when you do statistical averaging, a weighted average is a way to increase your quality.
The actual answer is the way that they distribute the weight is based on the R value.
So
Because
you
would
have
use the-
asserted. You've asserted multiple times, yet you can't show where in the document they've done that. You've just asserted it over
Well,
and
don't
over.
worry.
Oh,
I
you have.
would be happy to.
I'm not worried, Austin. I know you won't be finding it because
You
your
say that.
imagined insertion of the radius is not in there. You just really hope it is because it's your religion.
Oh, hey, does a reference spheroid have an R value?
Of course it does. Yes, Bessel and Clark are two excellent examples.
What's the Clark method?
The Clark method, like I said, I think you're talking about the Bessel method, and I don't know it offhand. No.
It says Clark method. And what's the least square? What's the least square method?
What's the least squared method?
Yeah.
I
How do you
can't-
determine the bell curve?
Yeah, it's a statistical thing, Austin. I'm not going to go over
It's
the
based
statistics
on the
with you.
R value.
No, it's not. I'm sorry. Least. Oh my gosh.
Yeah, in this case, it specifically is. That's what Clark said. Clark
To
said they use
to
the
a-
R value.
to a raw azimuth number, you're going to input the R somehow. I look forward to your
No,
your
that's a
work
straw
showing
man
that.
fallacy. Straw man fallacy.
It's a straw man fallacy.
It says they use a reference spheroid to distribute the weight.
Yeah.
What's so funny
And like
about
I said, and like I said, Austin, you're going to need to show how they baked in the radius because when it's a zero sum game, you can't bake in the radius because you must if they actually measured flat angles and they're baking in spherical angles, then they must put many more arc seconds of angle in there than 0.01 or 0.02. So you're going to
nervous
need to show
laughter is
that.
not convincing anyone.
Your homework that you have said that you I mean it's your assertion, so if you ever want to back up your assertion, will be to show the process that they used where they took the radius of the earth, input it into the math, and then that output the adjustments that they did for the averaging, like I said, in the East Coast ones, or maybe you want to look at the corrections from the base net, the corrections from the figure adjustments, those different things. You're going to have to show where in those processes the radius was put in, or as you've also asserted that the observed angles you've asserted are actually because they've used Bessel or Clark, that somehow those were put in. So you're going to need to show those. Those are your assertions. If you don't support those assertions, then by your own thing, how many clips have I played for you of you demanding that it's your standard, so you should be happy to match your standard of evidence, Austin, that you will back up your assertion.
Are you still talking, man? Holy shit.
Are you still talking, man?
You are really emotional today, man.
I don't even cuss, bro.
Yeah, you're really emotional. And of course, you also strawman me in that
I don't even
video.
cuss, bro.
Which in context of
cry
the video,
about it. Cry about it.
In the context of the video that you chopped out, I was explaining that I don't even cuss on my streams and I'm still getting censored.
Well, you do. But hey, one in the chat if you enjoyed that song.
So I did say a couple cuss words afterwards, but my actual point of the stream was, dude, I'm getting censored when I don't even go against TOS. I'm not even talking about things that should be censored, and I don't even cuss on my channel. And I was like, I don't even cuss, bro. I'm still getting censored. And then what you did was took it out, pretend I claimed that I never cuss ever, and then scoured the internet obsessively and very weirdly to find me cussing. It's just super gay.
It took all of 10 minutes.
Everything you
Austin.
do is gay. Everything you do is gay.
Austin, I write software. I know computers. It didn't take me long.
So I just laid out how gay what you did was, and you just like are prideful. It's weird.
It's
but anyway.
Okay.
Well, it is a
good job. Good job there, Austin.
You were intentionally dishonest.
Using that as an insult is so classy.
I find it weird. Oh, wow. Yeah, I'm sure you're one of those quote unquote Christians that love degeneracy. But my point is that you intentionally promoted dishonesty, pretending that okay, it doesn't matter. We can move on.
I'm going to love
everyone.
people, and you're going to hate people. That's the
difference. I love who do I hate?
Sure you are, Austin.
Who do I hate?
Yeah. Well, you're using gay as a derogatory statement, so I'm going to say those people.
Oh. Well, do people have a lower life expectancy when they're gay?
Hey, you're degrading them and you're hating on them. So you go ahead, dig that hole. Keep digging that hole, Austin. I'm going to instead choose to do what Jesus did, and I'm going to love those people.
Jesus would told them they shouldn't have been gay because they're going to die sooner. So if your son walks up to you, and asks, if your son walks up to you and asks you for money for heroin, listen, man.
Austin.
Hey man, can you calm down, man?
Let the hate flow from you, Austin.
I'm not being hateful.
Yeah.
So
you certainly are.
Sometimes
it's pretty disgusting.
Sometimes
it's really
showing
disgusting
love,
that you want to put your specific morals on other people who don't claim to be of the same religion as you even. So that's weird. That's really weird.
Can I finish talking? Or are you just
don't make it weird, guy?
Why are you being so impulsive right now, man? Like do you do drugs or something?
Because I'm talking you down from your hateful position, Austin.
I'm not.
That's
hateful.
why.
I'm trying to
because
explain
here
my position.
I'm speaking to you as an adult, and I'm speaking to you. I'm the adult, and you as the child in this situation. Right?
Hey,
you are the one that are being rude.
Pedophilia, is that hatred?
You are the one being rude.
Is pedophilia bad, McToon? Hey, is pedophilia bad, McToon?
Yes, it definitely is.
Wow, you're being so hateful. You hate pedophiles.
I definitely don't approve of what they do. Yes, and I think that prison would be great for them. Wow.
So I just want to point this out, man. My point is,
Austin. No.
Can I just make my point?
No, you can't. I'm not going to let you make this disgusting point.
Because only on the internet can you be tough, right?
Austin,
like all 5-6 of you.
Austin, no.
Virtue signal time.
I'm not going to let you make this kind of hate speech on
Dude,
Blue's
just go
channel.
read.
I'm going to hand it over.
Dude, your chat is the most hateful place on the internet.
Yeah. Glass houses, Austin. I'm going to hand it over to Blue, and I'm going to head out of here because I need to drive home.
All right, yeah, leave. So I'm just going to point out because you're basically slandering me. Like, I don't.
You deserve the slander. Go to hell.
Okay. See, like I just want to point out that the way that I view that, it's like if your child walks up to you and asks for money for heroin or something, like love isn't always just like advocating or permitting certain things. Sometimes love is telling them the tough truth that what they're doing is harmful to them. Like you wouldn't enable your son to go buy heroin, right? You would tell them no. Love doesn't just mean being passive and agreeable to everything someone does. Sometimes love is the opposite, but whatever. So anyway, I was just pointing out that he intentionally misrepresented me when I said I don't even cuss. It was just about I don't cuss in my streams to avoid being censored, but I'm still being censored. And lastly, he couldn't, and everyone heard it, you guys heard it, he couldn't even admit that he was wrong when he said that the corrected angle column is just based on the average. It's not based on the average. It's based on a spherical excess formula. So whatever. We'll get to the bottom of it where they use the ellipsoid model and they assume an R value and make corrections based on that. And if they distribute weight based on that reference spheroid, that is, of course, by definition, baking in the R value.
Wow. Suddenly it got silent. You know what?
Yeah, you can get 2 cents worth in that, Blue.
I'll tell you the 2 cents I'm going to get in. We've had this thing going for 4 hours and 38 minutes, which is about 2 hours longer than normal. So I think we've had about as much fun as I can stand for one day. Hey, but I want to thank everybody for showing up. Thanks to everybody out there in YouTube land that stuck around to listen to it. And Witsit, you're welcome back anytime. hopefully they didn't treat you too badly. I think you got your point across.
Yeah. No, thank you for being respectful, man. You're cool in my book.
All right. Well, with that, I'm going to say goodnight to YouTube, and you guys can hang out in here all you want to. I don't care. I'll see you guys on the next one. Let's end it here.